Docker is not a negotiable skill in this day and age. It's not something you should be wondering, do I need this? You absolutely do. If you do anything in tech, you absolutely need Docker. You need to know what it is, how to use it. You don't have to be an expert, but you need to know how to use it. Whether you are a QA or automation or in cybersecurity or you're just building AI tools, you're going to need to know Docker. And I've created this course with the beginner in mind to give you an overall knowledge of how to use Docker, what it is, and why it is so special. It's a full course that includes everything that you're going to need. It has 4 main sections. First, we're going to talk about the concept of Docker. Why is it so special? What does it do? How does it help us? So just the theory of Docker, we're going to talk about that. Then we're going to get into the actual application. We're going to do stuff with Docker, and we're going to use AI quite a lot. See, the way AI works is you kind of have to have domain knowledge. You got to know what to use it for. It's like a calculator, right? A calculator is useless for somebody that's not dealing with numbers. If you don't need to add numbers, to work with numbers, what is a calculator for? Nothing, right? You have to know what to use it for so you can use it. So it can make you faster. It can make you good at what you do. It's the same thing true with AI. Because AI is just a tool that's going to give you superpowers doing what you normally would do. So in this case, we're going to use AI to do stuff with Docker, but we got to know what Docker is for. We got to know what to do with Docker so we can tell the AI to do it for us a lot faster and a lot more efficiently. So we start to use AI as we start using Docker, right? We got to run containers. I'm going to teach you how to run containers, then I'm going to teach you how to use AI to run containers, and so on. So there are 2 use cases with Docker. We can use it to run existing stuff, or we can run our own stuff. We can Dockerize our own stuff. So there's a section about running existing stuff, and then we're going to get into a section of running our own stuff, creating an image and running our own containers. Then finally, we're going to get into orchestration like Docker Compose and things like that, and just to wrap things up and to make things a little bit easier for us. All the code we're going to use in this course is available for you. I'll put the link to GitHub in the description. Go ahead and download the code. So when we get to the action part, when we're actually doing stuff, there are example code that we're going to run. All of that is available for you. I also have this cheat sheet on my website. All the main Docker commands that we're going to do, that you're going to need, it's all in this cheat sheet. It's actually more than a cheat sheet. It's more of a tutorial because it has examples. It explains why we're doing what we do. So I'll also put the link for this in the description. Definitely, this is going to be your guide as you go through the course, especially when it comes to the action part. My name is Artemas Kung Fu. I run supersqa.com. I'm an SDET, software engineer in test. A lot of people think I'm DevOps because I talk a lot about Docker, but as a software engineer in test, even though we focus on testing, we're responsible for a whole lot of infrastructure. We're responsible for CI/CD. So we really have to know how to use Docker for our own purposes. So I got really comfortable with Docker over the years, and here I am. This is a small crash course that I created, but I have a full course. If you like this, I have a much bigger course in my program. I have an SDET program to help you become software engineer in test, starting from Python all the way to CI/CD. Go ahead and check out the details. I'll also put the link in the description for that program. Right after I finish recording this, I'm about to take this knowledge and actually Dockerize a real application that I'm building. I'm building this social media management application. Initially, I'm building it for myself, but I do want to make it public, like a SaaS, right? Software as a service. And right now that application is running on my local, just a Python Flask application, but I'm going to Dockerize it. I'm going to convert it as a Docker application, and I'm going to create a full-on CI/CD pipeline. So if you want to see this Docker stuff in action in a production environment, in a real project, make sure you follow that too. That's a build in public series. I will also put the link in the description. So you're going to see all the concepts, you're going to see practice, you're going to see examples in this video. But then after you learned it, you can watch it being used in the real world in a real application in the next video. So make sure you check that out and make sure you subscribe so you follow that build in public application live as I'm building it. So enjoy the course and let me know if you have any questions. I'll be very happy to answer your comments and your questions. We first have to understand the ecosystem of server versus application to understand Docker, at least to appreciate Docker. Docker is a tool, so we use it for something. What do we use it for? Is basically replacing that server application architecture. We have to understand that. So let's spend just a couple of minutes talking about that. Here I have example of 3 different applications, right? You have application A. It's a legacy application. It uses Java 8, a specific version of Java. It uses Apache, a specific version of Apache, Tomcat 9.0. And basically when you set up the server, you need to have the Java home variable pointing to this. and it needs some kind of configuration. So application A, you don't need to know all about these details, but it has its own requirements, its own libraries, its own packages, its own setup. Then you have another application. It has its own thing. Application B, it's a Python application. The first one was a Java application. This is a Python application. It needs a specific, it's actually a Python automation testing application. And it needs like a specific version of Selenium, specific version of PyTest, blah, blah. It needs Google Chrome. It needs all kinds of things. Then you have another application, application C, the same thing. It has its own dependencies. Another Java application, its own dependencies. And then when you're trying to run these applications, once you're ready to run this application, you need to put them into some kind of server to be able to run them. One of the options these days, what we're going to do is we're going to have, let me draw here. We're going to have one server each, right? We're just going to go in the cloud, rent a server. We're going to go to the cloud. This is my drawing, right? And we're going to add this guy into this server. We're going to deploy this guy into the server. We're going to deploy this guy into the server. So we're going to get individual server. We're going to get one server for one application, and we're going to configure. We're going to add everything to it, everything that we want, right? Application A needs A, B, C. We're going to add that. Application B needs X, Y, Z. We're going to get its own server. We're going to add that, right? A server is a computer. It's nothing but a computer for our code to run in. So we're going to rent that, and we're going to install everything we need. The other option, especially back in the days before the cloud, the other options you have is we're not going to have individual servers. What you're going to do is you're going to have basically one server, right? You're just going to get one server, and you're going to basically run all the applications onto that one server. It's much cheaper that way, right? You don't have to buy 3 different computers. You have one computer, you run everything in there. The problem now is they're sharing resources. They have the same environment. So application A needs Java 8. Application C needs Java 17. There's a conflict right there already, right? So that's always a problem. Application B needs its own thing. So you have to go into this machine and you have to configure it in a very complicated way when you want to have one machine and running a bunch of different things. A lot of times when you're doing development and you're running it on your local computer, local host, this is the kind of stuff you run into because you have one computer that's basically a server, and you have different projects you're going to run, and everybody has their own dependencies. That is an issue. So what Docker does is really completely get rid of this issue. Once we know what Docker does in the next section, we're going to understand all this problem goes away because of Docker. So you have to understand this part first. So what you need to get from this section is that an application has its own dependencies, its own configuration, its own setup, and you have to go set up the server to meet your requirement. In addition to that, let's say you set up the server, everything is working good. Now you're going to continue to work on your application. You're going to continue to make changes to your application, and you're going to change requirements as the application grows, as you add new functionality, new features. You're going to need new things. So once you test your application, everything is good to go with the new stuff, and you want to go deploy it to the server. Now the server has to be ready for you. The server has to accommodate the new changes you made. So now you have to go make a bunch of configurations to the server. That's another issue, right? There's going to be a mismatch with what you did on your local computer and on the server. You have to remember everything you did on your local computer in terms of configurations. Then you have to remember that and make sure that happens on the server. There's a lot of chances for errors. There's a lot of problems for discrepancies and disconnect. So that is a problem that existed for a long time, and we're going to see how Docker actually helps us solve that issue. So what does Docker do for us, right? So you get this concept of 3 different applications having their own requirements. So what Docker does is going to allow us to package that application with all its requirements as one piece, as one thing. And right now we got to take our application, all the raw code, put it into a server, make sure the server is working, make sure the server has everything the application needs. But with Docker, we take our application and we take everything it needs, all the dependencies, all the libraries, all the operating system, including the operating system. We're going to package it as one piece. It's going to be packaged, and then we can just go and plug and play. You take that package and you're going to just put it on the server. That server just needs to have Docker installed. Docker itself is a software, but our software is packaged in a way it has an operating system. It has literally everything it needs. And we're just going to go put it inside of the Docker player, let's say that, and it's just going to run the application. So this concept came actually from the shipping industry, and you're going to understand it once I show you what I mean, right? So think about back in the days when we have shipping containers or the shipping industry, different manufacturers, different companies, they package their stuff in different ways. Some companies will package it in barrels, some companies will package it in boxes, some in bags, some in pallets. As you can imagine, this is a nightmare for the transportation, right? For the trucking companies, for the shipping companies. This is a problem because they need different kind of machinery to handle it. As you can see in this image here, you're going to need a forklift for some of the types. You're going to need a little crane. You're going to need like human to actually handle it. You're going to need some kind of special, you need a dolly right here, right? You're going to need different kinds of equipment for the different types of package. So this guy, something Alexander, an American guy, he owns a trucking company, and he noticed this basically inefficiency, and he said, hey, we need a better way. We need a way to basically package all our stuff into one big container. And that's where the shipping containers came from, right? So he says, I don't care how you package your stuff. You can put your stuff in a barrel, in a box, in a bag, it doesn't matter. But at the end of the day, put it in this container. Now, my company, my trucking company, the shipping company, the docks, they know how to handle the container. So once you package your stuff however you want, you put it inside of a container, all you need to do is have a machine that can handle that container. Now that machine, the trucking company and the shipping company, they don't care how you package your stuff as long as you put it inside of a container. Their machine can handle it, right? And then you put it into a ship to go across the seas. You see how they make it so much easier for everybody by doing that. I'm trying to zoom out here. As you can see, initially it was just individual packages. You put it inside one package, it has everything you need. And then the people that are handling it, they just know how to handle that big container, no matter how you package the stuff inside of it, okay? And then they can just ship it across the sea. When you're looking at the Docker logo, the official Docker logo, that's what it is. It is basically a ship. It's a big whale. On top of it is a bunch of containers. So that's what Docker allows us to do. And that's hence the logo. What Docker allows us to do is, just like the shipping container, we're going to create an image. Now the terminology gets a little tricky. There's an image and there's a container. You run containers from images. We'll get there. When we get hands-on, when we actually do stuff, you will see that. But you get images. The image is the package. So the image is basically like a container. I hate the way they named it. Later on, container is not the image, blah, blah. We'll get there. But you package this at an image. Now all you need is a machine that can handle that image. So you have your software. You have application A. It has all these dependencies, Java 8, Apache, blah, blah. You have application B, Python 3, Selenium, blah, blah. You have application C. Each of those things have their own thing. So they're going to need an operating system. They're going to need this. They're going to need that. With Docker, you create one image. It has everything that application needs. So you got, let's call it image A. Then you're going to have image B that has everything this guy needs. You have image C that has everything that this application needs. Now, all you need to do is you need to just get a server, install Docker on it. Docker will be like the crane that can handle anything. So all you got to do is just take these images and just put it into the Docker, and the Docker could run it, because those images are isolated. They're individual, their own environment. It's almost like, right, some people hate it when I say that, but it's almost like they are their own little computers. So you get a big computer and you create a small little computer with your own application and you put it inside of your big computer. So you have the big computer, inside of it you have a bunch of little computers running. So what you do is you take your application and you package it in a way that it is its own little computer, aka a Docker container, a Docker image. You run a container from an image, and we're going to see that. When you package it, you create an image. That package is an image, and then when you run it, when you put it into a Docker play and run it, that is a container. You have an image, it turns into container. So a container is when the application is actually running. An image is just the package, okay? And I have another analogy to show you that's going to really help with this concept. So the DVD analogy, a lot of people like this analogy because it makes it easier to visualize, but it's funny. The first time I posted like a short video about this concept, somebody said, hey, Docker is not DVD. Come on, man. I didn't say it's DVD, but the concept actually makes you, it really helps you visualize what a Docker is. So when you think about a DVD, I mean, these days who uses DVDs, but I'm sure you know what a DVD is. It's a little disc that where you can just plug into a DVD player, hardware, and it plays the movie. Now, when you get a DVD, right, whether you have a Sony DVD player, a Samsung DVD player, or some other DVD player, or you or me and him and her, the same movie is going to play. My house, your house, exact same movie is going to play, right? As long as we have the same DVD, we take that DVD, we plug it into a DVD player, exact same video is going to play. We can change a few things about it. We're not going to change the movie, right? We're going to change the volume. We're going to change the color. We're going to change the language, right? There are some configurations we can do when we're running it, but the DVD is a DVD. The DVD allows for configuration. It's the same thing that is going to run everywhere, right? So what's inside of that image? What inside of that image is a bunch of files. There are video files, the main movie. There are audio files. There are files for the menu. There are files for security, for copyright protection. There's a bunch of things that go together to create one DVD. The main thing being the video and the audio, really, right? So the people that made the movie, they got all these files and packaged them into one DVD. So once they package them into one DVD, anybody with a DVD player can play it. So literally, that's what we're doing here. We take our code and we package it into an image, just like we package a DVD. And anybody that have a Docker player, aka Docker installed, they can just take that and just plug it in and just play it on their Docker player or on their DVD player, right? So, Docker is not DVD, not at all, not related in any way. But the concept is the same thing. You package something and you can play it anywhere on any machine. So hopefully that actually really, really helps you visualize what's going on here, okay? How Docker is working, how Docker is really helping us. So this visual here is basically saying the same thing. You have that application, you Dockerize it. So that's the term you actually can use, Dockerizing. When you take your application and you make it, you enable it to be able to run in a Docker. You can create an image. We're going to do that. We're actually going to do that in this course coming up. We're going to take an application and we're going to Dockerize it. So you Dockerize it, meaning you basically create an image, or you make it so it can be created as an image. And then once you have that image, you can just deploy it, or you can run it on anything, including your laptop. You're going to run it in your laptop. That's what we're going to do in this course. You're going to deploy it to a server, a different kind of server, no matter where. As long as they have Docker installed, you'll be able to execute your code on that machine. That's really the whole point of doing this. Why is Docker such a big deal in CI/CD? Why is it so magical in CI/CD? So in this section, let's talk about that. So first, when you understand CI/CD, you have to understand different environments, right? There's different version of the website before it gets to the public. Let's say I'm running supersqa.com. As soon as I write code, I'm not going to take that code and put it available at supersqa.com. I have to put it in a different environment like staging.supersqa.com or dev.supersqa.com or test.supersqa.com, something like that, or maybe even all of them. That is basically my code before it gets to supersqa.com. And the general public cannot access those websites like test.supersqa.com. That is restricted to be able to be available only from within a network. So my customers cannot see that, my people cannot see that. Only my testers, developers, engineers, anybody that works within the company can see that. Now you have to understand that, right? That's the environment. So when you look at this image here, developer will write the code goes into a Git repository. From a Git repository, the CI/CD pipeline will pick it up, put it into the dev server, and then things happen. If everything is good to go, we put it into a test server. If everything is good to go, we put it into a staging, then we put it into production. The customer can only access the production part. Now, so what is the role of Docker in this picture here? So let's talk about how it actually works. I'm going to try to draw something. Let's say we have the servers here, right? We got one server and we got another server. Let's just talk about two servers, okay? This is basically dev and this is test. Let's do this. This is going to be test. Now we got the developer. Let's actually do a little drawing. We have the developer here and it takes the code and puts it into Git. Let's say this is Git, okay? My drawing is a little slow, hang with me. So the developer puts the code into Git. As soon as the developer puts it into Git, the code goes into the development server or the dev server. So there is a CI/CD pipeline that's going to be listening to it for this and is going to put this in, right? And the developer, let's say, puts it into master branch. Well, normally that's not what happens, but let's say we create a merge request and the code goes into master. So as soon as everything gets tested and it passes, then we're going to say, okay, let's deploy it to test environment. So the code is now going to be copied over from dev to test. That's not how it works, right? What happens is it's going to say, okay, you're good to go. Then the CI/CD is going to pull the same code back into test because the assumption is it's already tested in dev. The same code is put to dev and then it's all good to go. So we can take the same code and put it into test environment, right? Let's say that happened at 1 p.m. Okay, let's just say that. Now, then there's another server here for staging. Well, let's just call it prod. Then we got prod here, okay, production. Now, when the tests are passing, everything is good. We're going to say, okay, everything is good to go. Let's go ahead and take the code from Git and put it into production. Now, what could happen is this is at 1 o'clock. Let's say this takes 30 minutes to process. The test environment, the automation and everything takes 30 minutes to process. So by 1:30, we're going to go to prod. Okay, 30 minutes passed, everything is good to go. Then at 1:30, we're going to say, okay, let's go ahead and put the code into prod. We take the code into prod. But at 1:15, right? At 1:15, a new code was deployed to master. Right at 1:15. Now what happens is at 1:30, when we take the code from Git, the master branch, and put it into prod, technically it's not the same code that was tested that's going to prod, because there is a new code that was added. There's processes to prevent that, all that. There's a manual thing. A human have to say, hey, we can't merge it to master yet because we did not push it yet, right? A human have to be the gatekeeper and make sure everything is good. Usually QAs, automation engineers, QA engineers, they have to do that. But that risk is still there. The developer checks in some code into Git while the pipeline is going on, and when the test is passed and we're ready to deploy to prod, we're going to take the master branch and deploy to prod. But between 1 o'clock when the test started and 1:30 when we push the prod, between then and the middle, there is a new code that was introduced. There's a new bug that was introduced that was never tested. We push it into prod. Okay, now that's a big issue. Now, how does Docker solve this problem? So now we have, just like we have a Git registry, let's say we have a Docker registry, right? This is Docker registry. So what happens is the way Docker works is when the day passes, there is another job here that says build image. Okay, so there is a process to build image. We're gonna build image build. Let's just call that. Okay. So then once the image is built, so the test happens, everything is good. The image is built. We put the image and we put it into the Docker registry. Okay. Then when everything is good to go and we're ready to deploy to test, we're not going to pull from Git. We are going to pull from Docker Hub or whatever the registry is. We're going to take the image, right? Then we deploy the image. This is going to be the image. We're going to deploy the image. Everything is good. We test it. And right after that, when everything is good, we're going to take the same image and deploy it to production. Okay. So from the first time we build the image all the way until we get to the production, it's the same exact image. There's no possibility of introducing a new code. So let's say we build the image at 1 p.m. right? That's it. That image cannot change. So one of the things about Docker is when you build an image, you don't change an image. You can build another image whenever you have changes, whenever you want to make any kind of change, you don't go and update the image. What you're going to do is you're going to build a brand new image. You cannot update the image. The way it's designed, that's not available. And that's what makes it beautiful. So once you build the image at 1 p.m., you're going to take that image and deploy it to the test server. You make sure everything is good. Then for the production server, you're just going to tell it the name of the image. You're not going to say, hey, we'll go get an image. You're going to say, hey, go get image 123, a specific image. So you're going to take that image and deploy it to prod. So between 1, when the image is created, and 1:30 when we deploy the prod, no matter what happens in Git, no matter how much code gets added to Git, the image never changes. So you are sure, you are guaranteed whatever code you tested is the same exact code that goes into production. And that is a beautiful thing. It's going to avoid a lot of headaches. Before, again, you deploy the branch, you test it, and you try to deploy the same branch to production, but between the time you tested it and between the time you deploy it, sometime in between, a new code could possibly be added. But with Docker, at 1 o'clock, you build an image and that is it. You know for sure that what is in that image, and when you deploy it to production, you know exactly the code that was tested is being deployed. That makes it really, really safe. Then another thing is, let's say you deploy to production and you run into a bug. You found an error, right? With Git, you can still revert, but it's a longer process. You have to figure out what the Git hash it is. You have to do Git stuff to revert to the old version. But with Docker, all you have to do is get the older image and just pop it in. It's like switching up DVDs, right? If you're watching a movie, you don't like the movie, you take the disc out and you put a movie that you like. That's literally what happens here. You'd be like, oh, we don't want this image. This image has a problem. We deployed this image to prod. Somehow the test didn't catch it, right? We didn't know there was an issue. It might be a configuration mismatch or something. But you want to quickly revert to the older version. So all you got to do is, oh, right now we deployed 1.3. right? Docker image 1.3, we're going to be like, oh, 1.2 was working fine. So let's just remove 1.3, put 1.2 back, right? Just like that. All you have to do is just switch the image. So it makes reverting really, really easy. So that's why Docker is really, really powerful. Like all this drawing here, if you watch it now after I drew it, it's going to be really confusing. But as I'm drawing it, hopefully it made sense. So now you have a really good understanding of why Docker really changed how we do CI/CD. It is just so awesome. It has a lot more benefit. I don't want to get it too make it too complicated. But even when we test it, we can spin up Docker containers. We can spin up a temporary application. The entire application itself, we can just spin up an application and test that, right? And just kill it, and just go to the production environment, right? We don't need an environment that's always running. We can just spin up an entire environment on demand. That's another thing. But what you need to know is it really avoids conflicts. It really avoids making sure the code that you deploy to prod is exactly the same code that was tested. That's number one. And number two is making a revert. Going back to the previous version is as easy as just switching images, right? So mention those things. If on interview, if you get that question, like why is Docker a big deal in CI/CD, just explain those two reasons and you'll be golden. Hopefully that made sense. So let's keep going. There are two ways we're going to use Docker. One of the ways is running an existing code, right? An existing application. Some people built their application, they Dockerized it, and they made it available in Docker so we can go and use it to run existing applications. You want to run application A, you just go find it and run it. You don't have to install it. You don't have to configure it. It makes things a lot easier to run things. That's one of the first use cases. The second use case is to Dockerize our own application. You build something, especially nowadays. Let's say you are vibe coding and you create applications. Then you Dockerize it. You make it very easy for other people to run, and you make it very easy for you to create CI/CD, to create the whole deployment. You take your own code and you package it as a Docker image or as a Docker container. So you Dockerize your own application. So those are the two ways we can run or we can use Docker. One is to run existing code, existing application. Two is take our own applications and Dockerize them, convert them into an app that runs in Docker. And we're going to see both things in this course. First, we're going to see how to use existing stuff. We're actually going to run applications using Docker. Then we're going to take code and we are going to convert it into Docker. We are going to Dockerize our application, okay? So where do applications live, or where do Docker images live? That's called container registry. I mentioned it briefly earlier, but you have GitHub for your code to live, right? You write code and you have a bunch of files, and those files you put them into GitHub registry or a repository, to a Git repository. GitHub is just one of them. It's just a brand. It's really most popular brand. But there's GitLab, there's Stash and Bitbucket. Like there's a lot of providers where you can take your code and you can store them there using Git. Git is a technology. GitHub is just a brand. It's a cloud platform. So you're going to use Git. You're going to choose one of those platforms, GitHub being the most popular one. You're going to put it there, right? And with Docker, same concept, but instead of files, you create an image. You take all your files, you Dockerize it, you create an image, and you take that image and you put it somewhere. When we look at our visuals here somewhere, all right, we talked about how you have an application, you create an image. If you scroll a little bit more here, we have our application. Basically, our application A is just a collection of files. It's just a lot of files, right? Our application, our software, whether it's web application or a desktop application, whatever it is, it's a bunch of files. And those files are packaged together into a Docker image. Then this Docker image needs to live somewhere. If you're going to put it into a server, how do you move it around? How do you take this? It's not a physical thing like a DVD. I gave you that DVD example. That DVD, you have a disk, a physical disk where you take into a DVD player. This is a software itself, but it's a package and it needs to live somewhere. And that somewhere where it lives is a container registry. Okay, and the most popular container registry is the official one from Docker Hub. It's called Docker Hub. It's by Docker, but you can store it in a bunch of other places. GitHub itself has a Docker registry, a container registry where you can build images and store them there. But Docker Hub is the most popular one, and we're just going to look at that. So you just go to your browser and search for Docker Hub. Right? You don't need to go directly. You can just search for it, right? Make sure you do this. I want you to do this. I want you to get your hands dirty. Basically, in this course, from now on, most of the things we do is hands-on. We did not install Docker yet. So right after this, we are going to install Docker. We're going to run applications. Okay. So I do want you to go to Docker Hub and look at it. So, fire up your browser, go to Docker Hub. Well, you are already in the browser. Just open a new tab, go to Docker Hub, and this is what it looks like. Okay. So in Docker Hub, it's just a collection of images. When you get to the homepage, obviously the homepage is going to look very different. Everything you see here is our images. They're Docker images. People publish those. There's 3 different kinds. There are sponsored ones, there are official ones, and there are like third-party ones, like you and I. I can create an image and push it into Docker Hub. I can store it. There's a free account, a paid account. The free account would allow you like one private repository. If you pay, you have unlimited private or just a lot of private repositories. That's just a little minor details you don't need to know at this point. But this is just when people build their images and they want other people to be able to use them, they upload them. Even for themselves, they just make them private for your own CI/CD. In your CI/CD, you need to get the image from somewhere into your server. So this is one of the options for you to store it. So everything you see here are images, right? Some popular one here, LangChain, this is like AI stuff. Python itself, right? Docker is one good way to run Python, different versions of Python. And when you build your own, you usually start with some existing image and you build stuff on top of it. So if you have a Python application, you're going to take a Python image and add your stuff to it and create a new image, your own version of the image. We're going to get that to the next section. When we're building our own Docker stuff, that's when we're going to use it. So everything you see here, like Confluence, if you have a job, you know what Confluence is, Nginx, right? Alpine, MySQL, Mongo, Postgres, all of those are databases. Databases are software and they are in a container. So whatever application you need, you're going to come here and you're going to pull it, right? Pulling means downloading it. We're going to see that in action in a minute. But this is a place where you have images. You can search for them. Let's say I want to search for Selenium images. I'm going to say Selenium. And I'm going to get a bunch of them that are, these ones are officially from Selenium, right? The account name / the image name. The account name / the image name. So all of those are Selenium. Like let's say if this is standalone Chrome. This is one of the examples we're going to do later on. If you need a little computer with Chrome installed on it and configured perfectly and has WebDriver in there and everything, so you want your code to use that new computer as the test platform, as a browser, you're going to use this image and you basically have an application where your tests can talk to, right? It's an application. Let's see another application. Let's say N8N. This is like really popular right now for AI workflows, for AI automations. There's images. This one is the official one here. So if you want to run N8N, which is an application on your laptop or on a server you own, like a self-hosted one, this is one good option to run it. You're going to run it using Docker because they already packaged it. You don't have to install it. And normally you would, like, if you don't want to use Docker, you have to go to their website, figure out how to install it, figure out the dependencies. The problem with installing applications are you install one application, but that application might depend on a bunch of other things. So your environment, your computer has to be ready for that. If this application needs A and B and C, you have to make sure the computer has A, B, and C. But with Docker, they're going to containerize it. They're going to package it into an image with everything. They're going to include their application and they're going to put A, B, and C inside of there. So you don't need to do that. All you need is Docker to be available on your laptop. You're going to take this image and you're just going to run that application. They have all the dependencies. You can configure it. You can give it different properties as you run it, but mainly that's really all you need. All right. So that is Docker Hub. This is where you're going to come to find images. And let's go and start running applications. The first application we're going to run is just a simple WordPress application. And we're going to run that. But before that, we're going to install it. So let's go talk about installation, even though it's pretty straightforward. Okay, so in order to use Docker, we need to install Docker. And installing Docker is pretty straightforward. It's just like installing any other application. And once you install it, you're going to get a desktop application like this. This is on my Mac, and I'm going to go install it on my Windows here. Or if you're on a Mac, just go ahead and install it. It's pretty straightforward. On my Windows, I remember I ran issues before, so I uninstalled mine, so I can just install it in this video, right? We're going to go through it. But if you already have Docker installed, go ahead and just fast forward a little bit or use the chapters in the description. But at the end, you're going to get a desktop like this. Even though we're not going to use a Mac, I'm not a fan of desktop. I'm a fan of using the command line because in the real world, you're going to need the command line, right? If you know how to use Docker, just using the UI. But then when reality hits, and most of the time you're doing this in a Linux environment, you're doing this in a CI/CD, if you don't know the commands, you don't know Docker. Okay, so I definitely don't want you to rely on the UI like this, but we're going to visit it time to time. It kind of helps visualize a little bit as you're learning, but I almost never use it. I use the command line all the time, and that's what we're going to do. All right, so to install it, let's just search by install Docker desktop, right? And we're just going to go to the page wherever it takes us. Here I am on Windows. It automatically detected I'm on Windows, so it's going to take me right there. Desktop setup, Windows install. So I'm going to choose the right Windows version you have, and I'm going to just do the first one here. I believe that's the one I have. and is going to download, and we're just going to wait for it to finish downloading, and we're going to install it. I want to go through the Windows part because there was one piece that I have a hard time. It's going to ask you to use WSL or not, and on my computer I'm going to use no WSL. So you can just try to do it with WSL, say yes, and then if it fails eventually, just start the whole process again and say no. That's what I did. It took me a long time because it wasn't working. I was just frustrated. Then I'm like, let me try it without WSL, and it worked. That's how I did it a while ago, and that's what I'm going to do right now also. All right, it just finished installing. I'm going to click on open file right here, and that should just open the installer just like anything else. All right, I'm going to say yes, and we're going to go through the installation process. So here, right, the first screen is literally the first screen. It says use WSL2 instead of Hyper-V, and it's recommended, but for me it's not working, right? I have a little old and small Windows. I have this like $200 Windows just for demo purposes. It's a small one. Whatever the issue is, it's not worth for me to investigate. So I'm going to uncheck that. But for you, especially if you have a newer window, go ahead and try it, right? Just select that, go through the whole process. If it fails, start the installation again. You don't have to download it. You already downloaded it. You just double click the exe, and there you go. Allow Windows containers to be used with this installation. You know what? I'm going to leave that out. Add a shortcut. Yeah. So I'm going to click on OK, and voila, this is just going to install it. Like I said, just like any other application, it's just installing the software. All right, it finished. Installation succeeded. We're going to close that, and it should be in the desktop, but we're just going to search for Docker right here. Docker desktop. We should get that little UI that looks just like the one we saw on a Mac. That's one thing I like about it. The UI is on a Mac and Windows is identical. It's exactly the same. Makes things a little bit easier. Of course, I'm going to accept, and it's taking a sweet time. Over here, you can see it working. You see the little Docker and the little containers like flashing up and down. That means it's just getting ready. Usually, welcome to Docker, worker and personal. I'm going to skip this, right? I'm not even sure what that is, but you could log in. So later on, when you build image, when you create your own images and you want to push them to the registry, to Docker Hub, you have to be logged in, either to Docker Hub or to GitHub or somewhere where you want to keep your images. You're going to be logged in. But when you're pulling images that are public, you don't need to be logged in. That's one of the awesome things. All right, so here we are. The installation worked just smooth. There you go. This is the desktop application. You have containers, images, volumes. You have Kubernetes already, like before it wasn't in there. Now it's part of Docker. We're not going to do that. We're going to be focused on containers and images and a little bit with volumes, okay? And then this is a dark theme. It's just a theme, but the application is the exact same, guys. There's container, there's image, and volumes and everything else, okay? So we have the application now. The next thing to do is start using it. We're going to run our first application using Docker, and which is going to be the WordPress application. All right, now that we have Docker installed and ready to go, we are going to go ahead and run our first application using Docker. We're going to run the WordPress application, right? So WordPress is a very, very popular CMS. You don't really need to know about WordPress. It's just a website. It's a website that would help you build websites, I guess, right? You run it and you customize it to make it yours. So it is really popular if you want to create like a test website or something. One of the quickest ways to create a website is WordPress. So we're going to run it. It's a PHP application. It needs Apache web server. It needs a MySQL database. It needs PHP. It needs all of that. But what Docker does is it packages all of that for us, except the database. The database, MySQL, is its own software. So that's going to be another Docker container. WordPress is going to be another Docker container. And WordPress is going to talk to the MySQL server. In this case, we're not going to go that far. We're just going to run WordPress, okay? And we are going to start using the terminal. So I have this cheat sheet, very detailed cheat sheet. It has tutorial, it has examples, everything. It's definitely a must have or a must check out if you're learning Docker, right? Which you are. So we're going to go through this. Actually, we're going to use some of the commands, well, pretty much all the commands that are here, but I highly encourage you to look at this because it has examples, tutorials, and everything, not just the commands. So we have this basic commands. Those are like the most minimum that we will be using. And we're going to use, I think the way I see it, we're going to use pretty much everything that's in here, maybe a little bit more, okay? And let's go to Docker Hub and let's search for WordPress. The first thing we need is the image. If we're going to run a container, we need to know the image. What is the image we need to run? And to do that, you go to a registry where images live, like Docker Hub, and you search for it. Docker Hub is the official one. So let's search for WordPress, right? So we're going to get one right here, the first one, which there's quite a lot of them. Sometimes you need to know which one is official, which one is not. Here, there are a couple of, oh, see, I have a typo. I just noticed that. I'm like, well, how come the official one is not here? I have a little typo here, right? Instead of word, I have wood. So I'm going to fix that. I was pretty surprised to see that. I'm missing an R. Now oops, let's see. I'm going to clear this, WordPress. All right, there you go. It's an official one. So you see a little badge. If you see a badge, there's 3 different kinds. There is official one, which is basically Docker themselves published. There's a verified publisher, like they have a relationship with Docker, and then sponsored. It's a little bit more trusted, right? Any of those, you're pretty good. If you're running containers that don't have any of those, then you kind of gotta like know where it's coming from, or you gotta know what you're using it for. If you're just playing around, who cares? If you're running a production database or a production application where you have customer data, you kind of want to know where it's coming from, right? Because you never know what kind of code they have in there. But you would trust the official ones. So here we're going to go to WordPress official. We're going to click that. Now, there are a few things we need to know. So as we're doing it, we're going to learn more, right? So far, what we learned about is the concept of Docker. What is Docker? Why does it make a difference? How does it make our life a lot easier? That's what we've been learning so far. As we're using it, there are going to be a lot of more things we're going to learn, okay? So just because you went through the theory part already, that doesn't mean you know everything. But as we use it, as we get our hands dirty, we're going to know a lot more. The first thing, for example, is tags. Tag just means version. That's the easiest one, right? When you're trying to get an image so you can run a container, remember, you run containers from images. Now's the time we're going to actually start to do that, so it would start to make more sense. So you got to get an image. The image is just like, think of it like just code, like a static code. It's an image, but it's just a static code. It's not doing anything. When you run it, it becomes a container. You run a container. That means the application. So you can take one image and run a bunch of containers. That's kind of how load balancers work. If you have the software running on one computer and you have a bunch of traffic and you need more power, you just create another container with the same image. So it's going to be the same application running multiple times, multiple instances, accepting traffic. That's a whole different story, but image, container. So what we're going to do here is we're going to download an image, or we're going to pull an image. So you're going to specify what tag it is. So in front of the image, you put a tag on it. Usually there is latest. You don't want to use latest on production, but if you do latest, as you can see, there is latest here. If I can make it a little bigger. It's basically the latest version. You don't want to use latest because it's always changing, right? Let's say today I execute latest and I'm running the latest version, and tomorrow they publish a newer one that has something new that I'm not expecting, or is going to interfere with me. If I keep running latest, I'm going to get the latest one and it might break the stuff that I'm doing. So usually you want to be specific. Let's say I want to say specifically I want to run WordPress 6.9, then 6.9 is 6.9. Right? So you want to avoid latest. I'll come back and talk about why we want to avoid latest. But for now, while we're practicing, we could do latest. So when you scroll down, so there is a lot of tags, right? If you're deep into it, you want to know what the difference are like. If you're really into WordPress, right now we're talking about WordPress. If you want to know exactly, hey, like I'm so very, very detailed into WordPress, you want to know what the difference is. Like right here, they have CLI 2 PHP 8.1, CLI PHP 8. What's the difference? For you and I, it's probably no difference at all. But somebody that's like, daily doing PHP stuff, daily doing WordPress stuff, they might care. But normally you just want the latest tag, not the latest itself, but like in this case, it looks like 6.9 is the most up to date. You probably just want to run that. Then normally when you scroll down, you will see instructions on how to run. A couple of things you would need to know. You will see later on. If you are on a Mac that has M1 chip, the Mac chip versus an Intel chip, there will be 2 different kinds of images. Docker automatically will manage that for you, but sometimes you have to give it a flag. Just be aware of that, and you're going to see the error or a warning. Usually it's a warning, and you just have to add a flag, and it will be fixed. We'll see that on a Windows. You don't have to worry about it. You always have like Intel or AMD. The structure, the architecture is the same, so no issues on Windows. But on Mac, you have to be conscious if you have a Mac chip, M1, M2, M3, M4, or you have Intel. Right, you just be aware of it. You will know when it comes up. All right, so now that you know that, you scroll down here. There are instructions how to use image. Right, so Docker run. This is one of the first commands. If you look at the cheat sheet, I have it right here. Docker run. It runs a container. Docker pull. It pulls an image. So you can do Docker pull, which will download the image, and you do Docker run, which will run the image. But when you do docker run, if it can't find the image, it would automatically pull it. So we don't even have to do pull. So docker run would automatically pull. Anyways, so we look at this command. We can run this. This is not really complete. I don't know why they put it first. You need a little bit more information. There is environment variables that it can take. Right? We don't have to worry about that. We'll look at environment variables later on. Environment variables, the actual concept of an environment variable is really important. If you're like totally beginner in this world, in this engineering world, you gotta know environment variables. I'll link a video in the description that I just published recently, like a week ago, about environment variables. They're very, very important to know. And in the Docker world, they become really, really important too. So scroll down. I'm hoping you're doing this with me. Please do it. Get your hands dirty. Just play with it. That's when it's really fun. Scroll down. There's one more command here. We want to run this command because it has this option, this -p option, which means you can access the container from the outside. Okay, so we're going to run this guy here, docker run. We're going to give it a name, -p -d. Now these are options. The command is run, right? That's a docker command, and you're going to give it options, and we're going to talk about those options. And here in this cheat sheet, they're all covered, but we are going to discuss what those options are as we go. Okay, so let's try that out. So what we're going to do is we're going to use the terminal. I'm going to do it both on Windows, just the first couple of examples, but you will see it's the exact same thing, so you don't really have to worry about it. When you come here, this is the UI. I don't really use it much. Other than to just look at it. Like if I want to start a new container, I don't even know how to do it, but I'm sure you can do it. Also, you can just click around here. How do I run a container? Run Docker Hub images. Yeah, I guess you can run Docker Hub images. You can just play with this. I don't want to spend time on this because this is a crash course. I want to get to the point, the most important things, which is being able to just use it in the terminal. So I'm going to open a terminal. All right, there you go. I have terminal. I have iterm. That's just what I like. Terminal iterm. It's not going to matter. So now there are a couple of commands. Let's look at. I'm just going to encourage you to look at this. So I'm going to go back and forth a little bit here. Let's say you want to get a list of images. Docker images will give you a list of images. I want to show you I don't have any images. So if I do Docker images, hit enter, there are no images because I did not pull anything. Another command is to see containers. There is images and there is containers. Docker ps shows you a list of running containers. So let's try that. We're going to do Docker ps, and that shows me running containers. Again, I don't have any running containers, so I need to run a container. But now let's go ahead and run that WordPress command. So we're going to copy this command here, and to make it easy for you to see, I'm going to put it into actually Sublime. You can do Sublime, you can do VS Code, it doesn't matter. All right, so here, let me make it a little bigger. So this is the command here, Docker run. You don't need the $sign. Docker run, it tells it to run. Then it's going to give the container a name, right? So the name of the container that's going to run is going to be some WordPress, some -WordPress. So --name. That's one of the options. It's optional. You don't have to give it. We're going to see it. If you don't give it a name, it's going to give it a random name. It actually does some funny stuff sometimes. Then we have the port mapping. You're going to have -p, the port of the host. So in this case, the host is the machine where it is running. Right now, where's Docker? Docker is on my laptop. So the host is my laptop. My laptop is the host computer. And then -d is basically running it as detached. Don't attach it to the terminal, run it in the background. That's what -d mean. This port one is really, really important. We're going to talk about that. And then the image you want to run. WordPress, if you don't specify the tag, it's automatically going to do latest, but you could specify the tag. Right now, let's just specify that. And we're just going to run it. Let's just get our hands dirty and just run it. Command C. And I'm going to go to the terminal, paste it. Docker run --name WordPress -p 8080. I'm mapping the port of the host where it's living, right? The machine to the ports of inside, right? We're going to come back and talk about what does it mean port and server. You got to understand what server IP address and port mean. We're going to do that right after this. I'll explain that. That's probably one of the most important parts to understand what's going on here. I'm going to allow it. So what it's going to do is going to pull the image, like I said. If you see what it said here, unable to find image WordPress latest locally. So it's pulling the latest from library, from the official place. It automatically knows, unless you configure it, it automatically knows to go to Docker Hub. Remember I said there are other registries. There's a lot of registries. You can have images in GitHub. You can have images in AWS, everywhere. There's pretty much everybody supports images nowadays, right? To a registry. So when you don't configure anything, Docker by default will go to Docker Hub. I said WordPress is going to go check Docker Hub for WordPress, unless I say check at a specific place. All right, it finished, right? So a container must be running. We don't see any error. The command we run is docker run. So there must be a container running. So I'm going to do docker. Let me clear this actually. To see a list of containers, what was the command? You got to remember that. I want you to be familiar looking at that stuff right here. Docker PS, list of running containers, okay? So we're going to do docker PS, and you can see a list of running containers. Right now we have one container. It's too big, so it's wrapping into multiple lines. But if I make it small, you can see it's just one long line, right? You have the container ID. You got the image for that container. It is running right now, right? The command that's run inside the container. The container now is a program, some kind of application running. For that application to run, some command inside must have run. Whatever it run at the start. For the container to start, it must have run something. It shows you here. Usually it's not that important right there for you to see. Then when was it created? 59 seconds ago. It's been up since then, so it's running right now. The ports, so this is basically localhost 000 and 8080. This is a port we mapped. You're saying on the host, on the local host, on this computer where Docker is running, you take the port 8080 and you map it inside the container 80. So if you want to access this application, this is where we're going to access it. We're going to copy that. And then there's a few more things you don't really have to worry about right now. In the name, some WordPress. That's the name we gave it when we told it to run it. When we run the container, we gave it -- name. If you remember our command, where is our command? Is -- name. Okay. So if you want to access this, all you got to do is go to a browser right here. And we're just going to go to that. Oops. Let's get back. It's 000. Let's this guy here. Every time I highlight the copies. Let me delete this. 000 8080. You hit enter. There you go. Now this application here, this is WordPress. This is a typical WordPress. Like, the application is running. It's not usable because there's no database and everything, but at least the WordPress part of the application is running, and that's what we care about. And you access it through this link, basically, localhost 8080. Okay, those are the key things. So we literally, what we did is we followed the official instruction and we used this command. We literally ran our first application using Docker. Now, a few things. How do you stop it? Okay, so let's look at few other things. If we look at this cheat sheet or just common commands, docker stop, docker rm to delete, docker rmi to delete images. Okay, let's practice those real quick. So I'm gonna make it big again so you can see it. Let me clear. First of all, the images, right? If we do docker images, you see one image is downloaded now. The repository name is WordPress. The tag is latest because that's the one we downloaded. It has an ID. Images have IDs. Containers have IDs. Image becomes container. You run a container from an image. I'm going to continue to remind you that. Created 5 days ago, that's the image, when the image was created, even though I just pulled it. And the size of that image. If we try to delete this image, docker rmi is delete, and I give it the ID. You can give it the name and the tag, like WordPress latest, right? We can do that to delete it. It's not going to work because it is being used, right? There's some conflict. It says container blah blah is using that image. So the container will need to be stopped and deleted for us to delete the image. So now let me clear this. If I do docker ps, I can see the container is running. So I can stop it. So I can stop it using the ID or the name, right? So I'm going to do docker stop. Let's just use the ID this time, the container ID. This is not the image ID, this is a container ID. Stop. There you go. And docker stop. Now if I do docker ps, it says there's nothing running because docker ps shows you all running containers. If you want to see all containers, whether they're running or not, you're going to do docker ps -a. You're going to add the option -a as all. I believe it stands for all, to see everything. So right now it's showing you all the containers. Right now we only have 2, and it was created 4 minutes ago and it exited 19 seconds ago. Okay. Now we haven't looked at the UI, but if we look at the Docker UI, if we go to images, you see the image here, right? It's easier than Docker images, but I want you, again, I'm going to repeat myself. The reason I want you to use the terminal is in the real world, a lot of times you're using the terminal because either you're doing it in CI/CD pipelines, so in a configuration file, or you're doing this in a Linux environment. So you don't have this pretty desktop UI. So I want you to learn the commands. And again, it's not that many commands. It's pretty easy. So we got the image here. we got the containers. You can see it is stopped, right? There's a play button or a start button. That means it is stopped. Let's start it. We can hit this button to start, or we can go to the command line. We can do docker start. Either we take the ID or we take the name. So let's take the ID again, the container ID, and we're going to start. Right now, if I do docker ps, I'm going to see a running container. If I go to the UI, you can see the container is running because this is green right here, and there's a stop button, right? So that is a container running. So we have one image, one container. Now we could literally run another container if we want to. I mean, we can take the same command. Where's our command here? If we try to run the same exact thing, it's not going to work because the port is used and the name is used. So we'll have to change the port. We'll have to change the name. Let's do that. Let's check. Let's use the port 8181 and let's change the name to some WordPress 2. Now this should run fine, and it should run pretty fast because the image already exists. It doesn't have to pull the image. So let me clear that. Let me paste that command, hit enter. Voila. Very quickly, it started to run because it did not need to pull an image. The image is there. From an image, you create as many containers as you want. So if you do docker ps, you can see two containers running right now. They're two different ones, two different ports. So literally, we have two different applications running. And the way you get to them is through different ports. So you have to understand what a port is. So this will make sense. What are we doing with the port? How come we only change the 80, the host port, and we did not change the port? I need to clear this. We did not change the port in the container. So let's go and look at what does it mean port, right? Just a quick summary of port versus IP address, the relationship. All right, so let's talk about the port mapping. It's very, very important to understand the port mapping when we have that docker run command. Whenever we run a Docker container, which is its own application, an application inside of an application, it's running on your computer and you need to be able to access it. And to be able to access that application, this is in a case where you have a service, right? Like a website that's running or some kind of application that's always running, not something that just starts, do something and dies. Usually you don't need to access those. But if it's an application that needs to accept network traffic, you have to deal with the port. When we look at our command to run containers, we have this -p blah blah, and that is really, really important to understand. So what I'm going to do here is I'm just going to talk about just the concept of what these ports are. So we're going to keep it simple. Here I just drew up a little bit of a demo here that will make it very easy to understand for somebody that's just getting started. If you're already familiar with this, just hang with me. It's just going to be just a few minutes, okay? So let's imagine this a computer, right? This is just a machine, right? It can be a laptop, it can be a server, whatever. It's just a machine, a physical machine, and you have ports into it. And the easiest way I found to visualize this, okay, is through an apartment. You look at an apartment. How do you get to an apartment? You have a street address, right? You say, hey, I live at 123 Main Street. Once you get to that address, you need to know which unit the person you're looking for lives, right? You have an apartment, a street address. You get there with the street address. Once you get there, you need exactly unit number. If Bob lives at unit A, then you have to go through the door of unit A. If Bob lives at unit B, you have to go through the door of unit B and such, right? So on the computer, it's pretty much the same concept. And there are about 65,000 plus ports. We cannot use all of them. There's a bunch of them that are reserved. There's a bunch of them that are special. And there's a bunch of them that are just open for us to use for whatever we need. So the first concept you have to understand is that, right? When you get to a computer has an address. That address, instead of a street address, you have an IP address. So an IP address is just a location of a computer. When you want to get to a particular machine, you go to that IP address. Once you get to that machine, there are a lot of things running on that machine, a lot of different applications running on that machine. You want to get to a particular application. So you need to know which port to go through. The same way, once you get into an apartment, you need to know which apartment, which door to go to, which is a port. Okay, so that's one way to visualize it. Now, this next one here, we visualize you have that application, you have that machine, and you have different applications basically running on that machine. You have one website, another website, you have a MySQL database, another database. There are different applications running on there that need to get traffic, that need to accept traffic, right? So to get to those applications need to be listening onto a particular port. So this little blue circles represent the application living inside of that machine, right? That one little machine. Then each of these applications need to be connected. That is up to the application. Whenever the application is configured, it is configured to listen on a specific port, and that port needs to be available. And some applications have defaults. For example, MySQL, right, is a well-known thing that MySQL by default listens on port 3306. Now, it can be configured to listen on any other port, any other open port, but by default, it's listening to 3306. If you have a web application, by default, it's normally you listening port 80. Just 80, okay? And you can have another application listening into port 8081, another one listening into another one. So when you run this application, when you configure this application, you specifically have to say, hey, if you accept traffic, you're going to accept it through this port. It's like if you're moving into an apartment, hey, if you're going to accept guests, you got to let them know this is the door to log in, door number 1, door number 2. Same thing, you have one application here, you have an address, and you have the port. And usually in the address bar, when you're trying to get to it, whether it's an API call or even in a browser, when you want to try to get to it, what you're going to do is you got the IP address colon the port, right? IP address is the address, the location. Once you get there, which door you're going to get into is basically the port. That's how I visualize it, right? Some people are going to be like, oh, it's not a door. Yeah, it's not, but it helps you visualize things, right? So that's how I want to teach it, at least. That's how I want to help you visualize it. So you got an application, you have a machine, you have a bunch of applications running into it, and to get to those applications, you got to go through a port, right? Remember that. Now, when it comes to Docker containers, what are Docker containers? A Docker container, the way I visualize it, is its own little computer, right? A container itself is its own little computer running inside of your computer. Right now, it's my laptop. When I have a Docker container running on my laptop, I have like another small machine running on my machine. It's almost like it is a virtual machine technically. If you want to go into it, how it works, the backend, everything is different, but it's a virtual thing that acts just like its own machine inside of your machine. Just think of this as a container. So a container is like its own computer, it has its own operating system and everything. It shares stuff with the host, but to visualize it, just think of it as its own isolated thing. And inside of that container, inside of that little machine, you run your application, right? That's what a container is, a Docker container. When you have a Docker container, you have your own little machine. Inside of it, you can run any application you want, whatever you configure. Now you take that Docker container and you put it into one machine. You just host it. You have a host machine. In this case, our laptop is our host. Whenever you run Docker, we just finished running the WordPress application, right? So when we run a WordPress application, we run it on our laptop. So our laptop is the host, is hosting that Docker container. And that Docker container, if you look at it like with a glass by itself, it's its own little computer, right? Just the analogy, it acts just like its own little computer, like a virtual machine sitting inside of your main computer. So when you think about it, this drawing here is a big machine, right? That's like your laptop, your server, wherever. It's a big machine, any computer, and inside of it you have different containers. You can run multiple containers. We ran 2 different WordPress instances, 2 different WordPress containers in that machine, right? And remember, we had to change the port, and that's going to make sense here. So here in your laptop, on your machine, or whatever the host is, wherever Docker is installed and running, you have multiple containers. In this case, you have application 1, application 2, application 3, application 4. You can have as many as you want, as long as you have enough resources like memory, CPU, the disk space, and all of that, right? It's not unlimited, but the technology is not the one that's preventing you. It's literally the physical resources you have, right? Think about an apartment. Inside of an apartment, you can have a lot of units, but all those units are going to share the electricity. They're going to share the water. They're going to share the gas. Whatever resources you have, you're going to share them. Same thing when you have a big computer, and inside of it, you have little computers. They're all going to share the same CPU. They're going to share the mother CPU, right? The host. They're going to share the host memory, the host CPU, everything. They're actually going to share that. But to visualize it, think of a big computer, inside of it, little containers. Those are our Docker containers. Those are the ones we are learning right now. Now, the next thing we're going to need to do is, sure, you run these little computers, little containers inside your computer. But how do you access them, right? Each one of the app inside of the computer needs to be connected to a particular port. So when we look at this, let's say this guy is Jenkins or this guy is WordPress. Let's look at WordPress. WordPress itself, the blue one is the application, right? The application needs to be connected to one of the ports. So the application is going to be connected to port 80. Now, this is the people that designed the application. The people that designed the container said inside of the container, inside of that little computer, the application needs to be listening on 80. They decide that, right? If you build your own, we're going to build our own eventually, very soon. We're going to decide what port our application needs to be listening at. So when you run a container, you run a little machine, and that machine is listening at port 80. Now you take that machine and you put it on the bigger machine, right? So the traffic from the outside is coming into the bigger machine. The traffic from the outside is coming into the bigger machine. So the traffic comes from the outside and it needs to go to your little application. So those ports, the little application is port listening on 80. The big application, you can map it 80 to 80, but 80 is probably like taken. Let's assume it's taken. So you're going to choose any random port that is available. Maybe not random, but that's available. And you're going to map it. You're going to say, okay, when you come from the outside, the host machine 81, any traffic that goes through 80, 80, 81, 81 in this drawing, any traffic that goes to 81, 81 needs to be connected to 80 for this port. Now on the same machine, you cannot use 81, 81 anymore because this container is connected to this guy. Let's say you have another container, which is MySQL. MySQL itself is inside of a container. Inside of that container is listening 3308, 3306. Now, this is decided by the people that created MySQL Docker containers or Docker images, right? When they containerized it or Dockerized it, they decided, hey, inside of our container, we're going to listen 3306. We do not control that at all, right? But when we run it on our host machine, this big machine is our host machine, we can control, hey, which port is available. So if we want to get into this machine, we need to map it. So in this case, we're going to say on the host machine, 3300 should be mapped to 3306. So the Docker command looks like this. When you run the Docker command, it's going to be docker run-p 3300, 3300, that's the host machine. Traffic coming in will go through there and it's going to go into 3306 inside. So the 3306 we cannot control, but the 3300, whatever open port we have, we can use, right? Out of the 65,000, again, there is thousands we could use. Out of those, we just choose whatever is open and we just use that. Let's look at another example here. We have another container, Jenkins, right? Jenkins is running inside of a container. Jenkins is the application. The application is inside of the container. Inside the container, the application is listening to 8080. So if we want people to come from outside to our host, this is our host, our main server, which our container is running. You want to get to that. So we're going to map 8080 in the container to 8787 in the host. So people need to go through 8787. So the Docker command is going to be docker run-p 8787, right? Mapped to 8080. So the thing on the left is always the host. The thing on the right is always the container. So you don't control what's in the container. You do not control that, but we control. Anyone you want to access the application, use localhost or 0000, well, 4 zeros, and the port 8787. Okay, so this is a little demo. Hopefully this makes sense. If you want this drawing, let me know. I can just print this as a PDF and send it to you and make it available. But yeah, let's keep going. I just want you to understand when we run our Docker command, the most important piece here is the port. If we don't get the port right, if we don't expose any port or if we don't mount the port, the application would run, but we won't be able to get into it because we need to connect the port of the machine, right? This guy to the port of the container. All right. All right, let's run another application. It's just going to be more practice, same stuff. We're going to talk about a little bit more options when we're running the commands. In this case, let's run the Jenkins application, right? If you are in a QA automation or in any kind of development job, you know what Jenkins is. Jenkins is a CI/CD tool. It's really popular. It's been around for a long time. So if you want to spin up Jenkins locally, Docker is one of the easiest options, one of the best options out there. And even in production settings, they might be running Jenkins in Docker. And for agents, like there is a master and there's an agent or a controller and agents. The agents are pretty much always Docker these days. So that's not what we're trying to get into. Let's just run one application called Jenkins. So we're going to start with Docker Hub. We're going to go to Docker Hub. We're going to search for Jenkins, right? As easy as that, because we want to know what the image is. Here we got a semi-official image, which is a sponsored image. So we're going to get that. There's another official one right here, but it says deprecated. It still works, but by the time you're watching this might be gone. So we're going to go to this one. And Jenkins can get a little complicated. There's a lot of settings we can set up with Jenkins, but we just want to focus on the basics right now. We just want to run the application. What we're learning is Docker, not Jenkins. I get a lot more into this in my Docker course and my full 4 hours course in my program. In that one, we focus a lot more about getting Jenkins to run properly. Even in my Jenkins course, I run it using Docker because it just makes things really easy. It will give you a nice little environment. All right, so now here when we come to tags, there's a lot of tags. We can just use the latest one if we want to, or this JDK 21, the latest. And in the overview, this one's a little bit different. Not a lot of documentation. It's just a link to GitHub. There's literally a link to GitHub, a lot of information there. And we're just going to take one of the first commands and we're just going to run that. So what we're going to do here is take, let me see, I think we're going to take this guy here. I don't see anything complicated. So let's take this guy. We're going to copy that. I like to put it in my notes so it's easier to see. I have the one from earlier and here we are. And you can break down the command. In fact, let me delete this to make it easy to read. You can break down the command into multiple lines with a escape character like that. And we're going to come back and look at what each one of those options are. Okay, so we need the escape character here. So this is basically just saying one long line. Just if you want to put it in the next line, we just add this in front of it. Okay, all right, so docker run, that's the command. We're trying to run a container. Then we're going to map a port 8080 to 8080. Let's change this one 80, because we're using 8080 for WordPress. We cannot use that anymore unless until we delete WordPress. Even though I deleted the container right now, we could have used it, but we're just going to change it anyways. So what this is saying is in the host machine, when you're trying to get into the container, you're going to use 8082. Inside of the container, the application that's running in the container, remember that container is like its own little computer, right? Inside of that little computer, where is the application listening? It's listening on 8080. We don't control that. That is the people that built the application. When people built Jenkins and they put it into Docker, they explicitly said, okay, our application is going to listen to 8080 port. So we cannot change that. But this one, the one on the host, so once we're the ones hosting it, we're hosting it on our computer, hosting it on our server, we control that. Depending on whatever port is available, we can use it, right? Not every port is available. So remember that the one that's inside, so it's outside, inside, outside, inside. The outside we get to control. The inside we have to use whatever the builders told us. In this case, it's 8080. We cannot change that. This we can change it to anything we want. This one we don't really have to have it. It's for agents and things like that. It's just a Jenkins specific, but the concept is the same. It's exposing a port, a -p is for port, from the outside 50,000, inside 50,000. The outside one we can change it. We can use anything that's available. Okay. Another option, this is the first one we're saying restart on failure, right? It just means if a container fails, it automatically will restart it. There's few options. We can say always. Always means just if the container is shut down, just start it. We can say always except when stopped. There's a lot of options here. So it's a lot of times what happens is you're running it on a server, right? In the middle of the night, the people that maintain the server, like AWS or DigitalOcean, they might restart the actual server, the actual host. When they restart that, you want your application to start again automatically. So we use that. That's just one option that I see being used often. -v stands for volume. What this means is we're going to mount some kind of folder in the container to the local drive. So containers, when the whole point of containers is so you can change them anytime. You can just get rid of, right? And when you have a new image, you spin up a new container. And when you delete a container, all the data is gone. You cannot recover it, right? When you delete a container, all the data is gone. So things like Jenkins, so things like WordPress, when you have to make changes and data gets written, that data gets written in that container, inside of that container, right? That container is like its own little computer. So data gets written in that computer. And later on, if you're going to delete it, is the whole point of using Docker is so you can just get rid of stuff quick, the whole application quick. If you're going to get rid of it, what's the point? You're going to get rid of all your data. What you're going to do is with volume, there's a concept of volume where you say you're going to take a folder on your local machine and you're going to map it to a folder inside of the container. So whenever the application writes into that folder, it gets written in the host, right? If that makes sense. In this case, it's using a named volume. So in Docker system, there's a volume. It keeps it in its own storage. It's on the side, right? And when you get rid of the container, that volume still remains. So you can run another container, mount the same volume, and all the data from the previous will be in the new container. I understand that's a little bit far. So what we can do here is we can change this into a real path. There's 3 different kinds of volumes. This is one of them. I don't want to use this. I want to be very explicit. So let's come here and let's create a folder. I'm going to say make dir Jenkins volume 1. Okay. So if I'm going to go into there, cd Jenkins volume 1. I'm going to do pwd. I'm going to get the path, right? Users admins Jenkins volume 1. Then I'm going to come here. I'm going to modify my command. I'm going to modify my command to say map or mount or map this folder on the host machine where Docker is running to this folder inside of the container. So what happens here is when the application is writing in this container. So in Jenkins, we know, like the people told us, the people that built it told us, hey, Jenkins is going to write into this folder inside. That container is a Linux container. Inside of that container, there is this folder. Jenkins, when you create a new job, when you create a new configuration, when you create a new user, whatever you do, all the data gets written into this folder. Now, what we did is whenever something is written in this folder, it's actually written in this folder on the local. So later on, when we delete the folder, when we delete not the folder, when we delete the container, the data remains. So we can spin up another container later on. So let's look at it. The only thing missing here is let's add the -d option to run in the background, detached. And then this is the image, right? We're running this image. Jenkins, the image goes to the end. The image is always at the end. Again, I'm going to repeat this, but I want you to really go over, if you're serious about learning Docker, this tutorial is awesome because it's compressed to like the key points, everything you need. I don't know if I have Jenkins here, but I definitely have MySQL. Yeah, I have Jenkins, right? Everything I'm talking about right now is definitely discussed here in detail. So I highly, highly recommend you watch this, okay? You go through this document. All right, so we're going to take this command and we're going to run it. Now let's go to the terminal. In this folder, I'm going to do ls. As you can see, the folder is empty. Nothing is in there. I'm going to run the container. Okay, we got an error -v. It says that we don't know what command not found -v. That's weird. Let's see. Oh, because we missed the skip character. We did not skip it here. Okay, let me come back here. Let me clear. Paste the command. There you go. It is running. It can't find the image. So it's going to pull the image. Remember, Docker run, you can't find the image, it's going to pull brand new image. It's pulling the image and it's going to run it. It is done. If I do clear and Docker PS, we're going to see the Jenkins one running. We never gave it a name. When you look at our command, we did not give it the name. So it's randomly assigning a name to it. Angry Cartwright, whatever that is, right? Angry Cartwright, that's the name of the container. And it's saying we can get to it with this IP address, 0000. The port we chose, 8082. So if we go to a browser here and try to go there, and there you go. This is literally Jenkins running on our laptop using Docker, right? And it's saying to log in, you got to get this credentials from this place. We also know that Jenkins logs stuff. So if you wanted to check the logs, another command is Docker logs, and you're going to take either the name or the ID of the container. I'm going to take the name of the container, Docker logs, hit enter. That shows me the last at maybe 100 lines of the logs. If you want to follow it, clear, we're going to do Docker PS, so I can get the name again, copy, Docker logs -f for follow and the name. Now we're following the actual logs. As whenever I do something, like you'll see, if I'm going to highlight this stuff here, I'm going to refresh this, we should see stuff in the logs, right? We should, or let me type something, hit continue. There should be some kind of errors. Or, okay, let me log in. This is a credential, actually. This is the password. I'm going to go put the password in, hit continue. I'm going to see stuff coming up in the logs. Should have. I don't know why it's acting like it's not. I'm actually surprised. I should be installed. Now it's installing plugins. Yeah, you can see like tons of logs because it's literally installing plugins. So that's the Docker logs to see the log. But what I want to show you is the container is running. If we go here, we can see one container running with the Jenkins image. Let me bigger with the Jenkins image. Okay, that's just another example of running Jenkins. So all we did is just to summarize this particular part, went to Docker Hub, search for Jenkins. They send us to this documentation. We came to the documentation and we looked at the command that they want us to use. The first one here, they're not using a volume. This one, they are using a volume. And the volume is basically you're taking a folder on your local machine and a folder inside of the container, you're mapping it so you don't lose your data. We're going to look at volume later on. When we containerize our own application, we're going to containerize or Dockerize a to-do application. Then we're going to revisit volumes one more time because volumes are really important to understand because you lose data if you don't have volume. So this has been an example of running another application using Docker. And this is the command for Jenkins. I'll put all this information in the description, of course. right? Let's go and run another application. So far, we saw two examples. Both of them have a UI, and both of them have the ones we run WordPress and Jenkins. They are web applications. So the application runs and you access it through a browser. It's a website. It's a web application that we did. But sometimes you run applications that do not have a UI, right? They're just a command line applications like Python. Python does not have a UI its own. It's just an environment. It's just an environment to execute Python code. So let's go ahead and run a Python container and see how we can use it. That's pretty straightforward itself. All right, so let's go ahead and take a look at that. The next container we're going to run is a little different because it's not going to run an application that is continuously running. It's not a service, it's not a website, right? We're just going to run a Python container. We're going to go inside of the container and just do stuff. So it's very, very simple. We could start by looking at what Python images we have available. So if we go look at Docker Hub, I don't know why it's doing this. Go to Docker Hub, search for Python. All right, this one is going to be an easy one. PY. Every time I have a typo, there's an image with it. It's crazy. Python, right? So this is the official one. You can see the badge. There's an official one. And you can see there are tons of tags, right? The most stable one right now is 313, even though 315 is out as like a beta or something like that. So let's run a container. Over here, I don't know if they have examples how to run it, but they have examples of how to create your own based on this and things like that, which is the next thing we're going to talk about. There is a little example on how to run it. The key thing we're going to look at is the interactive. Let me see if I can make this bigger. This IT option, interactive, we're going to look at that option. So we're just going to keep it simple. We're going to do it both on Mac and Windows. So on Mac, for example, if I do Docker images, you can see I only have 2 images locally, right? If I do Docker PS, you can see there are few containers running. It doesn't matter. As long as my computer can handle it, I can have multiple Docker containers running. So I'm going to make it a little smaller. I'm going to clear this Docker PS to see running containers. If I open the desktop application, you can see there are 3 containers running. Okay. Now let's run another one. Clear. So what I'm going to do this time, let's pull the image. One of the common commands that I want you to learn is the Docker pull, right? So here in the cheat sheet, in the common commands, there is Docker pull. Normally, when you do Docker run, it would automatically pull it. So you don't normally have to do pull that often, but I just want to show it to you because we haven't done it. So I'm going to make this a little bigger again. I'm going to do Docker pull. I'm just going to do Python. It's going to pull the latest one. PY. I have a typo right there, which I always do. I'm going to cancel this. I'm going to clear it and Docker pull Python. I'm just going to say Python without giving it a tag. It's just going to do latest. But normally you would want to be very specific. When we build our own images, you will see that we're going to specify exactly which one we want. So we're going to wait for this to finish. All right, so the image is pulled. It's not a very big image. Let me clear this. And if I do Docker images, now we have a new image, Python here. Okay, so what I'm going to do is Docker run. Let me make it even a little bigger. Clear, Docker run. Now I'm going to give it IT, basically interactive, right? You don't have to memorize what they mean. Those are 2 different options. -I is a different one, -t is a different one. But you usually just combine them when you want to run a container and go inside the container. So I'm going to just say IT, and I'm going to do the image name, Python, and whatever the command you want to run. Normally, I just do bin bash because I would just start a shell. I'll start a shell so I can interact with it. Now, look at this prompt changing, right? If this prompt changes, that means I'm not on the computer anymore. Like I'm not interacting with my system right now. I'm interacting with that container. Remember, containers are like a little computer inside of your main computer, right? So I'm inside of that little computer now. Everything I do, if you look at the user, is root, right? If I say, who am I? I'm the root user because I logged in to that machine as a root user. If you're familiar with SSH, it's almost like SSHing. You have a server somewhere in the cloud, you connect to it, and you do stuff on that server, right? That's kind of what we did here. We spin up a container, a Python container, and we went inside of it at the same time while we're spinning it up. If we look at our containers, I can pull up the UI. Now there are 4 different running containers. And when we ran this one, we didn't give it a name. So it gave it a weird name. I don't know, this one here, right? Quirky Freddy. We never gave it a name, so it gave it a random name. So it's a container. So inside of this, we are inside now. If I do docker ps, that should not work because in that container, there is no Docker. It is possible to run Docker inside of Docker. They call it D&D, Docker inside of Docker. But in this case, its own machine, its own ecosystem, its own everything. It does have Python. If I do Python dash version, Python dash version. Wait, I know you can do uppercase dash V, Python uppercase dash V 3410, but I'm curious why that didn't work. Okay, should have. I must have had a typo. All right, so 314 is running in this container. So when you do Python latest 314, now we have Python available, so you can do Python stuff. We're not going to do anything here, but you are in a machine that can run Python. So the point of this is to show you could run applications that are not websites, that are not continuously running. It's probably like a script that will do something and it will just die, right? That's a very common thing to do with Docker, like cron jobs and on the cloud, like for example, AWS batch, which is basically a scheduled job that would wake up, do something and die. So what you do is you take your Python script, whatever script you have that just does something and finish, you package it into a Docker image. So when you want to run it, you know you're going to run exact same code every single time. You just create a container, does this thing, and dies. So I just want to show you that. Quickly, we can do the same thing on Windows. On Windows, I like to use command prompt. I don't use Windows very much. So when I do, I use command prompt. So here, let's see if Docker is up and running. If I do Docker, if I just hit Docker, it should give me an error if it's not running. It is running apparently. So let's do, I keep doing clear CLS. We do Docker images. Oh yeah, it's not running. So we're going to start Docker because I restarted my Windows. Docker desktop. Let's go ahead and start that. Now the beauty with Docker is it doesn't matter what platform you're in. As you can see, I'm on a Mac most of the time. That's what I use personally. I'm really fast working on it. It's just really convenient for me. That's the only reason. Especially when it comes to Docker, it's the same thing. Okay. When you're watching this video, you're on Windows. The commands are exactly the same. Even the UI looks exactly the same. So everything you're learning here, whether you're a Mac, Linux, or Windows, it would be the same exact command. So Docker is running. Let's do Docker images. Docker images. There's no image. Now let's pull Docker Python. Docker pull Python. Same exact command. Docker pull Python. That's going to pull the image. And we're just going to wait for that. It's not a big image. It took a little longer than I expected, but it did finish. CLS, Docker images. You can see now we have a Docker image, a new one. The way it shows it in the CLI is different, right? On a Mac, we have a separate column for that. If I do, I'm inside the container now, get out of the container. I just opened a new tab. Docker images. On a Mac, the tag is its own column. On a window, it actually shows it. I actually like this because it's very, very clear. So we can just run this now, just like we did earlier. Docker run. The key here is interactive. We actually want to go inside the container. We're going to want to start the container, go inside the container and do stuff. We can do Python, bin bash, right? So I'm on a Windows machine, but this container is Linux. So now, in fact, this is very nice to see because now I'm inside of that container. Everything I do here is Linux commands because even though I'm on a Windows machine, it's like a machine inside of a machine, but that machine that's inside is actually a Linux machine. So here I am doing Linux commands. Who am I? I should be root. And we can do ls, dir, not dir, pw. I don't know how dir worked, but it did. So Linux commands. Basically, the whole point of this particular section is just to show you Docker is not just about running applications like websites like we normally do. We could also run like utility type of scripts, just small scripts, small application that would just run and die. Okay, so we're going to continue to look at more examples of running existing stuff with Docker before we start to create our own stuff with Docker. Now that you understand the main concept of running containers, you understand what the concept of the actual commands look like, you don't really have to write commands yourself anymore. The main thing is you understand what's going on, then you're going to have AI write it for you, right? Anything going forward, we just need to have domain knowledge, but AI is going to do the work. We are the directors, right? So far we saw how to run containers. We saw a couple of different options for the run command. Now we're going to let AI do all the work for us. Anything we do going forward, we're going to do AI. For example, the stuff we've done already, we're going to ask AI to write it for us. So since everybody have access to ChatGPT. I will show a quick ChatGPT one, but everything I do is actually in Cursor AI. It's an IDE. It looks just like VS Code, but it's full-on AI, and it is really popular, and I highly recommend you do it. They have a free tier. It's pretty limited. You get 2 weeks of pro, I believe, and it's just an awesome thing. If you are a serious developer, a serious engineer, that is one of the tools that you have to use. That's the way I see it. But let's start with ChatGPT. So let's say I just want, give me a command to run a WordPress container. Remember I told you WordPress is MySQL and WordPress. It doesn't do anything by itself. So I'm sure the AI is going to try to give me the full thing. I just want to, for the demo purposes, I just need it for demo. So only give me the command for WordPress and not MySQL. This part you need to know about the application. Now I just randomly chose WordPress. You don't really need to use WordPress, right? If you already know the application WordPress, it would be fun for you to use WordPress because you know the application. But right now we don't care about the application. We just care about Docker. So here, as you can see, it gave us this command. This is the exact same command we got from the documentation and the one we have. Literally, if we look at this, except the name of the container is WordPress demo. It used 8080. It used the latest one. It's running it in the background. Pretty much everything. The order of the options is not going to matter. The only thing that matters is the image has to be the last thing. The image has to be the last thing. Other than that, right now in this example here, you can see -d is early. Here we have -d always at the almost at the end. Okay, so that's how it will do it. But let's go to Cursor. So this is Cursor. This is the code I'm using for this course. I have all of this, what you see here, available for you in GitHub. Right, you just click on the link and you can just go download it. It's going to be in the description. So here it works just like ChatGPT, except it has access to the file. Normally what you would do is you would go to ChatGPT, you get something generated, you copy it, bring it over to your files. But when you use something like Cursor, now Cursor is not the only one, it's probably the best one. But if you want like a free one, I think the one Google released, anti-gravity, that is pretty good. It's pretty new, so everybody's talking crap about it, but it will get there for sure. It's Google, but it's free, so it's much better. But this is the one I'm using, and this is right now is like the de facto, right? It's just the main thing that is the best out there, and I'm building a lot of things with it. So everything I like to share with you guys. So Cursor. So what I'm going to do here is, let's see, hide this. I'm going to say create a shell script. Well, actually, let me create both scripts. Create scripts to run Docker containers. Two scripts for Mac and Windows. I'm going to do it for CMD, so it's a bat file. On Windows, there's too many kinds of shells you can have. Right now, if I didn't tell it that, most likely it's going to do a PowerShell script. You have PowerShell, you have WSL, you have CMD, you have Git Bash. You have a lot of different options on Windows. But on Mac, you just use Bash. I mean, you have Z shell and stuff, but everything is the same. Right, so for some reason, it's taking its time. Normally, this thing is really quick. Right now, it's taking its time. I have the model selected to auto, and it's going to do it. And I'm just going to wait for it. Docker containers. I did not ask it. I did not tell it what. The containers are for WordPress. Without MySQL, just simple WP app. Okay. I have to be a little bit more clear. I'll try and explain things, so I skipped that. I didn't even tell it what container to run, so it was. I think that's probably why it took a long time trying to figure it out. So we're going to wait for this. It's basically just going to create it into a file. So what happens is, when you have commands, you can take the commands and run them in the terminal directly, or you can put them in a script in a little file, and you can just run that file. It's much easier. So basically here, for example, we have this, right? I can just save this as .sh because this is on a Mac. Or I can save it as .bat, just a file, a simple file, save it, and in the terminal, I run the file instead of running this whole command. So what makes it easy is, if we need to make small changes, the file is so much easier to change than on the terminal. On the terminal, you got to go find the place you want to change. If you make a mistake, you have to start all over again. But a file is, you can just come and just change it, save it, and voila, you just run the script. Now, that's kind of old school. It is really powerful. I use it a lot, but now with Docker, there is a thing called Docker Compose that will do this for you in a script. Docker Compose. So that's one of the next chapters we're going to talk about. It's coming up. So after this, we're going to talk about building our own stuff. After that, we're going to just seeing Docker Compose. It's a part of Docker That makes things easier, and we'll get there very soon. So I'm trying to be really comprehensive with this course. Now, the problem with AI is going to write so much complicated stuff, right? Look what it's doing, because it's writing a script that is very robust, right? Handling a lot of errors for you. It's not just like ChatGPT gave us just one command, because we asked it to give us a command. We didn't ask it to write a script. But this is doing a lot of stuff that looks complicated, but it's probably just checking right now, is making sure that if we're going to run a container, making sure another container doesn't exist with the same name, right? Saying, hey, stopping it, and then stopping the database and deleting it, and then starting another one. Then you're going to come here and you're going to see all the options. We know about -d, it just means run in the background. We know about name, you're just giving the container a name. Now there's a new concept, a network. We never seen this option, right? The network option. The beauty with AI is you're going to come back here and be like, oh, I noticed you used network. Can you explain? There's a way to do it here too. Like you can just, you can do a keyboard shortcut and ask it to explain. Then you can just come here and like, I see you used -- network option. Can you explain that to me in easy to understand way? Right? So now it's almost like you're talking to ChatGPT. It's going to explain to you, but you have the stuff right there next to you, and you go back and forth. You can see it. So now it's literally going to explain it to you. So network is this and that. So Docker containers, they need to be in some kind of network so they can talk to each other. We talked about accessing them from the outside earlier when we do the port mapping. But normally you have different containers talking to each other. For example, WordPress container, MySQL database. WordPress container needs to talk to the MySQL database, and they have to be within the same network, right? That's going to be a little advanced, but that's what the network is for. If you notice here, that's what it's assumed. It didn't even expose any port. Okay, did not even expose any port. Let's see. This is Docker runs. Oh, this is doing this the database. Even though I asked it AI, right? AI is so smart, but at the same time, I asked it no database, but there you go. It did the database anyways. He's like, nah, I'm not going to listen to you. I'm just going to do it anyways. It happens a lot. If you use AI a lot, you will notice how it doesn't really listen to you. So that's why it got me tripped up here, because I did not expect the database. It did. But look at the WordPress part, exact same thing, right? So the point is, we already talked about these commands, but how you use AI with this. You literally tell it, you know what you want. You know you need a command. So now you're going to tell it, hey, write a command for me. Put it into a file. And it's going to do stuff you don't understand. Then you're going to ask it, hey, explain to me. I didn't understand that. I didn't get that. So in this case, we have a lot of variables. Those are environment variables, okay? -e, when you run a container, you can pass in environment variables. Environment variables are an extremely important concept. There will be a link in the description for you. I create a video all about what environment variable is. It's the most basic thing, but the most important thing also at the same time. So when the application needs, the way that the designers design that application, it needs some information. It needs environment variables. And in the Docker run command, you're going to pass it as -e variable value, -e variable value, as many as you have. And here we are. It gave us a script for a Mac or Linux, and it gave us another script for Windows. It gave us .cmd. I'm not even aware of that. I thought it would do .bat, but this is the same concept. At the end of the day, the command Docker run, and this is all one command. It's adding this little thing here, the caret, for continuation. Okay, so that's an example of using AI. We're going to continue to use AI for everything we do going forward. Let's look at another example of how we use Docker to run existing stuff and make our lives a lot easier. This time we're going to look at an example in the QA world and automation world, which for automated testing. So in this example, we're going to see how Docker helps us run Selenium tests a lot easier. Selenium tests are, the bread and butter of QA automation for the front-end testing. What Selenium does, if you don't know, is it will basically open a browser and it will interact with the website just like a human would, and that is a test. So you write the code, instructing Selenium, hey, open this website, go here, click that, do this, type into this. You tell it what to do step by step, just like a user would do. It will do that, and if there is some error, it will let you know. And normally we have the browsers running on our machines. We have the browsers running on our laptops when we're developing, and then we will put the code into some kind of Linux environment, a CI/CD pipeline, and some kind of server, and the browser needs to be available. And usually that is a nightmare, installing the browser, setting it up. Usually it's a lot of work. Even in Docker containers, when we want to create our own container with browsers inside of it, it is quite difficult to do. But what the Selenium people did is they gave us official images. They gave us Docker images that's already set up. It has everything we need, all the browsers in there. And we just have to let our test run the test on that remote WebDriver. So this is the concept of remote WebDriver. Normally we'd run local WebDriver, but there's a concept of remote WebDriver, which is basically your code is running on one computer, but the browser is on a different computer. And you tell your code, hey, run the browser on this other computer. And there are companies that do business like this. You might have heard of Browser Stack, where they have tons of different types of computers, different types of mobile devices, and you pay them to run your code on their machines, right? Let's say I have a website and I want to test it both on a Windows and on a Mac, both on a Chrome and a Firefox, right? I need to create all that infrastructure, or I can just pay them, run the code here on my machine, but tell the code, hey, run it on Chrome on their computer, run it on Firefox on their computer, run it on Windows on their computer, right? So that's called a remote WebDriver. Now what happens is Selenium gave us those containers, so we can just spin up a container that has everything in it, and we can just tell our code, hey, run it in that container, okay? So let's just quickly take a look at it. We're going to go to Docker Hub, and we're going to search for Selenium, just so you can see what is available. So we want to do Selenium, and usually we have the official ones right here, right? Selenium standalone. So this is standalone Chrome. Actually, I should go back. We have standalone Chrome. We have the hub, which is a grid setup. It's a whole different thing. I'm going to create a whole video how to use grid. Basically, you click one run button and it's going to run it and multiple containers at the same time. On Firefox, Chrome, blah, blah, whatever you set it up in parallel at the same time. So if you know what Selenium grid is, that's what it is. But you can see there is a standalone Chrome and Node Firefox, standalone Firefox. They should have like Edge. So you have a lot of different supported browsers as containers. And all you do is just spin up a container. Now you have a computer basically waiting for traffic, waiting for your tests to run. And then you just tell your test to run there. So I'm going to show you to do that right now. So let's start with this standalone Chrome. I'm going to do standalone Chrome. If you are a QA, I want you to try the Firefox just as practice. So when we see here, it shows us, hey, this is how you're going to run it. Okay. Again, we can just go to AI and ask it how to run it. Let's go ahead and run this command. It says, hey, to start the container. So first you start the container. As you can see, it's running in the background. Let me see if I can get this bigger. It's running in the background. It's mapping this port. Those ports are kind of special. Just follow the instruction. It's very unlikely that you are using this port already for something else. This port, it's not a very common port. It's an open port, but most likely it is available. So that's what we're going to use. This is very important. Basically, you're giving it extra memory. Right? Remember, containers, when they run on your computer, they share some memory, but they're not allowed to share everything your computer has. By default, there's a specific amount they're allowed to. Here, when you run in the container, you're telling it, hey, use at least 2 or maximum 2 GB of whatever this special type of memory it is, okay? And this is the image, as you know. So I'm going to copy that. I'm going to open the terminal. I'm going to do this on a Mac. You can do it on Windows. It's exact same thing. Now let's look at Docker PS. I'm going to do Docker PS to see the containers. I have tons of containers. Well, maybe 4 containers, right? That Python container, the Python, the WordPress, another WordPress Jenkins. I have all of those. I can just run one more. If I do Docker images, right? Let me zoom in now. You can see I have 3 images. I don't have the Selenium one. So I'm going to clear this. I'm just going to put that command again. Let me go copy it, paste it, hit run. It's going to run in the background because it has -D. Okay, so saying I can't find it, I cannot pull it. All right, this is a great opportunity here because this is complaining about my platform. I'm on a Mac M1 chip, right? So I have to give it an extra option. Now, if you get warning like this, I'm just going to take that, right? I just got to do -- platform Linux AMD 64 or something like that. But I'm just going to go to GitHub. I mean, to ChatGPT and be like, hey, running Selenium container got this error. I don't have to spell it right. ChatGPT just knows what it's trying to do. It's going to give me, hey, add this option. I'm not sure why they don't include it here. Let me Control F. Platform. Yeah, they never mentioned it. Platform. Yeah, they never mentioned it here. But so this is for you guys that have a Mac computer with the M1 chip, M2, M3, M4. So with the M Apple Silicon, you're going to run into that with some images. The people that publish this, they're supposed to publish different ones, and Docker is supposed to manage it for you, but sometimes it doesn't, as you just saw. So let's look at the response to ChatGPT. It's saying, hey, you just got to add this extra platform, Linux MD64, just like I said. So we're going to go back here. I'm going to clear this. I'm going to hit the up arrow to repeat my command. Okay, I got my terminal got messed up. I'm going to open a text editor. I'm going to open a new one. Going to go get the command again. This is really what I like to do. I like to put it inside of a file, so it's much easier to work with. Copy this and add it as one of the options here. Okay, so it's the same thing. All we did is we added an additional option, this platform Linux MD64. Take that, Control Z, paste a new one, hit enter. All right, now it's pulling it. It found the kind of image that's compatible with our machine, with my Mac machine, and it's going to put it on Windows. You probably don't need that. So let's go on Windows. You're not going to run into that issue, the platform issue, right? So I'm going to copy this guy. I click copy. Seems like it gives me a hard time sometimes because I'm connected remotely to my Windows, so the keyboard shortcuts are weird. I'm going to open a new one, and I'm going to see if I can paste it here. It's not working. I have it copied into sticky notes. Let me copy it right there. Copy. And it is really weird because I just tried it and it was working. Right here, I'm going to see if I can copy it on the next line, paste it in the next line. The issue we faced with the platform, that is only for Windows. For Mac. So Windows users, you don't have to worry about it. If you have a Mac with the Intel chip, you don't have to worry about it. It will just work. This one would work. You don't have to specify the platform. All right, so the image finished pulling and it also ran. So if we do Docker PS, now we should see a Force 1 running. I'm going to make this smaller and I'll just zoom in when I'm editing the video. Right, let me clear this. Docker PS. You can see multiple containers running. One of them is the standalone Chrome. We have a Chrome 1 running. It is accessible at port 4444. Now, if we go back to look at the documentation, it says, okay, once we run that, we're going to point our WebDriver to that address. And if we want to see what's going on inside the container, it says it gives us a link. So we're going to click on that link. This is going to open. This is called a VLC. It's a way for you to, it's like a fake monitor inside of the container. So we can see what is going on while the test is running. So let's go look at our test now. I have some sampled ones. And if we go to this project here, and if we go to Selenium Docker examples, we got two files here, right? Local driver and remote driver. You have access to this code. I'm sending you this code. It's in the link, basically. You get it from Docker, from GitHub. So let's run the script just to show you. Normally, what do? We need to install the dependencies. I probably could have prepared this, but let's go open the terminal. We're going to put us into the project root. I'm going to go to CD, Selenium Docker examples. I'm going to do Python 3-m -v. I'm just going to create a virtual environment and install Selenium inside. This has nothing to do with Docker, really. -v, activate, pip, install Selenium. All right, so as we can see, while this is going, let's see. This is a local driver, right? The local driver, what that's going to do is basically just opening Chrome. It's going to open Chrome. It's going to go to my test site. It's going to get the page and just print it. So let's run that. I'm going to say Python get title remote. No, I need local. I don't know why this is acting weird. There you go. So I'm just running the local driver. This is going to open a browser on my machine as a difference, right? This is literally right now, it's actually downloading a browser and running it. It's running it in a headless mode. Okay, now let's run the script. I'm going to do Python example get. I have a typo here. I have get twice and I'm going to run that. So right now this is running Chrome on my computer. As you can see, Chrome opened, it went and got the title and dropped. Now the remote one though, for the Chrome, I'm going to tell it the address. Remember where our container is running? If we look at our container here, the Selenium container is running on port 4444 on localhost, right? So we're telling our Selenium our Python script saying, hey, for the website or for the browser, go here. This is the browser I want you to go to. And there's a special code you have to write to tell it, hey, to go there and do it. Let me put a little sleep. So there's a 2-second sleep so we can see it. Let me make that a 4-second sleep. And I'm going to run it. I'm going to say Python example get title remote. Hit enter. This is going to actually connect to the remote. You can see it, right? This is inside the browser. This is the link they gave us to see what's going on inside the container. Let me run it one more time. You can see a browser open. This is a little like fake window to be able to see what's going on inside of the container, right? So in short, this is very relevant to people working on automation, people that run automated tests, Selenium tests, Playwright tests, and things like that. But the main thing is they give us a container or an image, and that just makes our life so much easier. Anybody that has been working on Selenium and trying to work on it with Docker by their own custom image, they know how much painful that is. But this is really, really beautiful and easy way to do that. And I'm going to create a bunch of videos on how to implement this in CI/CD, right? This is the most powerful thing. Locally, you just run it local, no problem. But in CI/CD, using those images gives you a lot of powers. And if you are into QA, make sure you follow, because I'm going to create a lot of videos already planned out how to use this concept in a CI/CD pipeline. All right, so let's go ahead and look at how to build our own images. So far, we've been playing around images that are built by other people, but we can look at another example. Now it's time to look at how to run our own containers, how to run our own image, how to create our own images and Dockerize our own applications. So far we've seen how to use existing images to run containers. Somebody wrote some code, created an application, they Dockerized it, pushed the image to a central place, and when we want to run that application, we went and got the image and we run it, right? We run a WordPress application, we run a Jenkins application, we run a Python application, we run a Selenium application, right? We did all of those with existing images. Now, how did those images make it to the registry, to Docker Hub, right? How did they get there? How did they build it? Now, in the next section, we are going to build our own images, and we're going to build this simple to-do app, which is a Flask application, a Flask Python application. We could run the app quickly, and you have the code here. So this is the repository. When you go to GitHub, this is the repository you're going to see, and there is a to-do app folder here. And this is the application itself. We're going to build a Docker file right now, and I'm going to check it in later on. But let's go ahead and run this app first. So I have it open its own project here. And instead of going back and forth to ChatGPT, I'm going to use Cursor. So when I ask it questions, when I ask it to write the code for me, it's just going to do it right here in the files. And that's what we're going to do. We're not going to write Docker file from scratch. I'll explain what Docker file is. We're going to let AI write it for us, and I'll explain it to you. Because going forward, you're not going to write anything yourself. You just need to know the concept, especially when it comes to something like Docker file. You're not going to write it yourself, right? Not in this day and age. So to run this application, it is pretty simple. Before you can Dockerize something, right? Before you can take an application and make it run in Docker, you have to know how the application works, because the Docker is basically like configuring it. It's almost like you configuring it. What does it need? You have to tell Docker when you create that package. Remember, Docker is nothing but you take everything that application needs to run and you package it together into a Docker image. So when you package it, you got to know what it needs. What do I package in there? What does this application need? How does it need to be configured? So normally you need to be able to run the application without Docker just so you can understand it. Normally, sometimes it's too complicated. It's easier to just jump and do it in Docker anyways. But normally you probably want to run the container, run the application without the container and see how it works. Then you can containerize it. So for this Flask app, it's a very simple Flask app. When you pull it up in GitHub, you're going to see the README. I have detailed instructions what you need to do. You should be able to run it. So run it first and then Dockerize, right? This is hands-on course. Go ahead and do the stuff as I'm doing right now, right? You can pause the video and execute as I'm executing. So all we got to do is create a virtual environment and install dependencies and just run this python.py. If we run this python.py, the application is going to run. Even if you're not a Python background, you should be able to do this. You should be able to follow, because a step-by-step, and it's like 3-4 steps that we have to do before we get to the Docker part. I'm going to open the terminal. Everything is done in the terminal. I'm going to open the terminal. It's automatically going to put me in here, and it's going to create a virtual Oh, there is a virtual environment, so it used it. So let me delete that. Deactivate. I was just practicing earlier, preparing for this. I'm going to delete this virtual environment, so I'll create a new one. All right, so let's create a virtual environment first. The README will tell you to do that also. So I'm going to use Python 3. By default, mine is 3.12, but it's not going to matter. VNV, I'm going to say VNV to do. Let me just call the virtual environment that. Now virtual environment is created. Again, if you're not a Python person, don't worry about this part. You can do this execution or you can just skip the virtual environment part. It's just a very simple thing in Python, but initially it's a little confusing. So I'm going to activate it. Source VNV to do, then activate. If you're on Windows, you just do the same thing on Windows with different commands. You got to know about virtual environments, which I have plenty of videos on my channel about virtual environments, because a Python developer got to know virtual environments. So it's activated. I'm going to do pip install -r requirements. Right now, just pay attention to the steps. We activated a virtual environment. We're installing the dependencies. Right, the dependencies in Python project are in requirements.txt. We need Flask, Jinja, and markup safe. Right, just these basic things here. Normally you just need Flask, but this app needs a few more things. The installation finished. I'm going to clear, and all I do is run this app. When you just for context, this app is going to run on port 5151. So we're going to see Python or Python 3, won't matter in this case. I'm going to do app.py because Python is Python 3. Oh, I have to do Python 3 app.py. There you go. So if you see this, that means the application is running and you can get to it with here. I'm going to, with this address, control click. I'm going to say cursor now has a built-in browser, which is so awesome. But I'm going to do external one. Here it is. This is the to-do app. It's just a simple Flask app. You can add to-dos. You can create to-dos. And it will store it. It will remember it, right? I can say create task. I'm going to say learn Docker, use a new crash course. I'm doing this on purpose. So I'm going to create it, right? So they're going to be learn Docker, use a new crash course. Remember this, right? We created this to-do list. The way this application works is the to-do lists are saved as a file, right? A real application would save it into a database, use some special S3 or Google Drive or something like that. Maybe not Google Drive, but use some professional way to store it. Here, the application, what it does is it's storing the to-do item as a file in the current drive, wherever it's running. It's running on my computer, so saving it on my computer. Remember that, we'll come back to that. That's going to be extremely important when we Dockerize it. There's a concept called volumes that we're going to talk about, and that is very important. So remember, when we create a to-do, it writes data. It's not the fact that it's a to-do. It writes data into where it is running. Right now it's running on my computer. The data is written on the computer. Okay. And if I stop the server, I'm going to Control C to kill it. Now the application is dead. Okay. Application is dead. I'm going to start it again. The application is start up, refresh. There you go. Our old to-do item is still there. Okay. Now we know what the steps are. We basically, in our local machine, we create a virtual environment, we install the dependencies, and we executed the script. Okay. So I'm going to tell the AI to Dockerize this application. I'm going to say, this is a simple to-do Flask app. Create a lean, simple Docker file to Dockerize this app. I'm not going to tell it much. I'm going to let it choose how it's going to do it. Like that, there are things like base image. Pretty much that's the biggest decision it needs to make, base image. So while it's doing that, it's pretty much done. I can explain what's happening. What it did is it created this file called Docker file, right? Specifically spelled like this. It could be spelled another way, just like any other file. You can just give it any name, but when you run it later on, it's going to matter. And you're not going to see that very often. I would say 99.9% of the time, you're going to see it called Docker file, right? Docker file. Just like this, no extension. It's a simple text file, no extension, Docker file, okay? Now, what is this file? This is a special file. I'm going to just say keep. I'm going to accept it. When the AI writes the code, the file is going to ask me, hey, review it. Do you want to keep it or not, okay? All right, so this is what a Docker file looks like. It has its own syntax. It has its own way of doing things. Let me turn on my spotlight. There you go. So the first thing is the from keyword. you're always going to see that. You're always going to see from, right, in uppercase as the first line of a Docker file. So when we build images, we normally don't build it from scratch. We're going to take an existing image and we're going to add our stuff on top of it, right? We're going to need something that's the base. So this is called a base image. So somebody asks you, hey, for this project, I can see a Docker file. What is your base image? Are you going to say, oh, my base image is Python 3.11 Slim. This is the name of the image. If you go to Docker Hub and search for Python and you look at the available tags, one of them is going to be 3.11 Slim, right? Right now, the AI chose to do that. We could have chose 3.12. It would have worked. 3.13. I wouldn't use 3.14 yet, but 3.13 is pretty safe. The slim part is like, it's basically a slimmer version of the image. It doesn't have a lot of stuff that we don't need. Just really basic one. So what it's doing is taking that image, and when we build our image, is going to start from that and keep adding to it. So for this application, we don't need to install Python itself. This image has everything that Python needs to be able to run. Another option we could have done, right? If we want to complicate things more, what we could have done is instead of from Python, we could have said from Ubuntu. Okay, think about that. Basically, a very simple Linux environment. Then, if we do that, we're going to have to install Python. Look at that. If we start with a plain Ubuntu, just an operating system, then we have to install Python. And usually we gotta stick with whatever they gave us, whatever is available. It can be an older version, or we have to do a harder way of doing this, a harder way of installing Python. So now we start from a fresh Linux environment, Ubuntu. Then we have to configure it for Python, or we can just use an existing Python image. To make it not confusing, let me delete this. We could just use an existing Python image that's already pre-configured for Python. It's perfectly configured for Python. We don't have to deal with that. We just deal with our own applications. So that's the number one thing you have to know. Is in a Docker file, the first thing you do is specify a base image. That's a keyword, a base image. You're going to take something that already exists and you're going to basically build on top of it. So here we take something that's a Python, basically an image that has officially supported Python, created by the official Python folks. Then we start to do stuff on top of it, right? We're going to add layers. Containers are images are basically layers. Like this is a layer of information, a layer of information, a layer of information. We take that layer. Then the next keyword, this is fairly, well, I wouldn't say fairly new, but when I started learning Docker, this didn't exist. I'll have to run a command that says make dir, like create a folder. So what this is doing is basically creating a folder in the root /app and going there. It's the same as saying make dir /app and cd /app, right? Doing two commands at once. Then what this is doing is going to copy this file, the file that you gave it. It has to be in the same location as the Docker file because we're not giving it a full path, right? We're just giving it's relative to where the Docker file is. Copying it into the image. This file is used to create an image. So it's copying it into the image, saying copy it here. Where is here? We are in the /app folder. Then once we copy that, we're going to run the install, right? Pip install no cache. This is just a simple pip command. And then we're going to copy everything else. Now here, when we do copy from here to here, it's copying also the Docker file, right? It's copying the virtual environment, which we don't need. So just be aware of it. We could set it up better, right? We could have the virtual environment outside. We could copy specific things. We can say copy task, copy template, copy view. We can copy the stuff that we need, but this is a small application. Typically, you have a huge application. You don't want to copy everything one at a time. You just want to say copy everything, but you should configure it so that stuff you don't need, you don't keep it in there. Also, there is a concept of a Docker ignore, just like git ignore. If you're familiar with .git ignore, which tells git to ignore some specific types of files, which you can list out. Then you can tell Docker to ignore things like that. You can tell it, hey, ignore any folder that starts with V and V because it's a virtual environment. Okay, so basically, it's copying everything in there, and then it's exposing 5150. port 5150, because it knows, the AI knew that's the port we need. This is going to run in a container. A container is its own little computer. Inside of the computer, the application is going to run at 5150. So traffic coming from the outside is going to have to go through 5150. We're going to have to remember that to be able to access the application later. Then we have the special command cmd, basically saying if you run the image, if you just run the image, this is the first command that's going to run. At runtime, we could override this, but this is what it's going to run. Now, this gives the system instructions how to build the image. So when we run the command to build the image, this is what it's going to do. So let's open a new terminal here. Windows, Mac, it doesn't matter. We're in the right place. If I do ls, I can see Docker file is here. So the command to build the image, let's go back to our cheat sheet real quick. There is Docker build. Okay, it's a Docker build command. There should be an example here. So what we're going to do is we're going to run Docker build. We're going to give it a tag, right? I'm going to say my to do. We can give it a version 1.1. That's a tag. The whole thing is a tag. The terminology is a little weird. That's also a tag. That's the version, but the whole thing is called a tag. And I'm going to tell it where to find the Docker file. I'm here because I'm in the same folder where the Docker file is. And typically, that's how you do it. If the Docker file happens to be in a different folder, then you have to tell it. You have to use the -f flag, and you have to literally give it the name. I can say dir my Docker file or something like that, right? You got to tell it the name. That's why I say 99% of the time, you're going to see the file called Docker file. That's it. That's literally the command. Docker build -t and the image name, blah, blah. This is on a Mac M1 chip. So it's going to build it specifically for Mac. Later on, we're going to talk about other things. So allow this. It's going to try to connect. It has to connect to download the image. So what it's going to do is actually literally going to pull the image, start to build on top of it, and build a new image. So this is successful. We don't see any errors. We see the commands that it run. There is one other flag that I don't see nobody talks about, but -- progress plane. This is like the old school behavior. I really find it useful, especially when I have errors, because it's one by one, it's printing out everything it's doing. So if there is an error while you're building the image, you will see that you'll get a lot more detail. So -- progress plane, that's going to be impressive. So, try to remember it or put it on your notes. All right, so now the image is created. If I clear this and if I do Docker images, we should see our my to-do with 1.1 image created, right? Simple. Now we could run the container. I got the ID, I got the name. So I can just copy the ID. I can say Docker run that ID. I can do -d to run in the background. But what's wrong with this? You have to remember, this is an application, right? It is running inside of a container, and it need to accept traffic. So if we don't expose a port, or if we don't map a port, this is not going to work. We could run it. It's going to run. There you go. It's running. It's running at 127.0.0.1.51.51. But this is localhost inside the container. You got to remember, a container is its own little computer. Now we have a computer inside of our computer. So when the application is running localhost, that is not the local host of our computer. That's the local host of the computer that is running inside of our computer, its own little container. So we can't access the application. If we go here, let's see, our other app is running. So we're not accessing the application that's inside of the container. We're accessing the application that is already running. Let's kill that. Okay. There you go. Now what we need to do is I'm going to kill this process too. This container is literally not usable. If I open a new terminal, and if I do Docker PS, it's hard to see here. So let me go here, Docker PS. We can see our app running. This guy, we didn't give it a name, so we gave it some random name. But no port is exposed. So there's no way to go inside of it and do anything. I mean, to see it from the outside. We can go inside the container, but that's not the point. So what we need to do is we need to kill this. And we need to run a proper command. So let's clear this. So we're going to do Docker images, but Docker run, that's our command. We got to map some ports. So from the outside, let's say I want 5555. That's the host. The inside is the container. We have to know where the application is running. It's 5151. We know that, right? And we can give it a name if we want. -- name my - to do. and then the image name. Oops, I messed up. So let's do the whole thing again. Let me clear this. Clear. Docker images. Docker run dash port 5555 5151 inside dash name to do. I'm just going to call it to do. It's fine. And I'm going to take the ID, paste the ID. All right. Still, I forgot to do the dash D. So it's running attached to the terminal. So we can see the logs as they're going. But now when we go back to the other terminal and if we do Docker PS, this will be zoomed in. As I know it's really tiny, it will be zoomed in. You can see it is accessible from the outside on port 5555. So if I go to my terminal, my browser, and go to 5555, there you go. Now this application is inside the container. I'm actually accessing the app in the container. If I look at the logs, the container is running, you can see logs coming here. If I go here, if I refresh, you should see a lot more access logs. If I do create a task, some random task, you can see the task is created and you can see all the calls being made, the add, the view task, all the calls. So all the logs. So we literally containerized our application. Now we have a Docker container or a Docker image here that we can run. So now every time I want to run this application, all I have to do is just run the command I just ran. I need to know what the port is, and I need to know what the image ID is, and I just run it. That's it, right? But this is only good for me because it is on my local machine. I can run it. Now I need to publish it. I need to push it somewhere so you can pull it and run it. So to Docker Hub. Docker Hub allows you to have one free private repository and unlimited public ones. You can have unlimited public repository. So I'm going to make this public. So the command is Docker push. You're going to push it. But we're going to tell the AI to write a script for us because when I push this image, it's going to be for the Mac silicon chip because that's how I built it. I'm going to tell it to build it for all kinds of platforms so anybody can pull it and run it on any laptop. Like for Windows users, you guys can be able to do it. So I'm just going to tell it, create a simple script to build and push the to-do image for both ARM and I don't know the right word, Intel chip. It will do it. It would know. The Docker Hub account is Super SQA. The image is to do, let me call it to do demo. And let me just say 1.1. Let's go. So this is going to do. Meanwhile, let's go to Docker Hub. Right? Let me see if I'm logged in. I'm not logged in. So to push it, you're going to push it into your own account. So you have to be logged in, obviously, right? Even in the system, I'm logged. If I open Docker Desktop, I'm logged in. You can see it here. I'm already logged in. So every time I start Docker Desktop, it automatically logs me in. So this is going to create a script. Let me see. It did finish creating the script, build and push. Let's just quickly look at it. But it does some fancy stuff that I don't want to get into right now. But what you have to know is it's going to build it. There's a build command. It's using build X, right? It's like a little plugin. But then at the end, it's going to be put push. And this is the name, right? So before the slash, anything that comes before the slash is the account. When we go to Docker Hub and search for things, let's go to Docker Hub. When we go to Docker Hub and you search for example, Selenium. Right? You see the account in front of it. Who published it? Selenium is the account and the image in front of it. So when I logged into my account, you can see I have a bunch of stuff that is under Super SQA. We look at to-do. I published the to-do app before, several of them, and we don't see the new one. So now let's run the script. Let's run the script that was created. I'm going to open a new terminal. I'm going to say it's a bash script. So on Windows, you would have to tell the AI write to a Windows version of this. Basically tell it, hey, I need a script to build and push an image. I'm going to say bash build and push. All right, there you go. So this script is running. It's going to build the image just like we did locally. It's going to build it locally, but then it's going to push it. Then you're going to be able to pull it. I'm going to actually leave it there. I'm not going to delete it unless I have to. So you can actually pull it and try it. You can at any time when you're watching this video, go ahead and pull the image and run it. In fact, we're going to do that right now. I'll delete it I'll pull the image and I'll run it. And after that, we'll talk about very important concept called volumes. And we're just going to wait for this to finish. All right, so if finished and there's no errors, so that means it pushed it, and it tells us, hey, I pushed it to SuperSQL to do demo 1.1. And if we come here and if we refresh, we should see a to do demo. There you go. To do demo is pushed. And when we're looking at the tags, the options, 1.1 is one of them. Now, if I create a new version, let's say I make changes to this app, to the to-do app, I change colors or add new functionality, new feature, or whatever I do, I just update the application. I'm going to push a new image with a new tag. I could push it with the same tag, but for people that are using it, you want to be obvious and clear that things have upgraded. So you will change the version. I can do 1.2, I can do 2.0, whatever it is, right? So that's the idea though. Now this is public, so I will have to add a description here, a category. I can ask the AI to write description for me, how to run it and everything. Let's go back to my account. I'll show you some image. Let's say to do app live, to do demo, my to do. Let's look at this one. If there is any, see there is like instructions about the application, right? A little how to run it and things like that. I don't want to spend the time here, but that's something we could add to the repository. So now it's public. You literally can pull it. Let's go ahead and delete the image here. The container is running, so let's stop the container. Where is it running? It's running here. Now let's look at some commands that we haven't used in a while. So if I do docker ps-a, we see all the containers that are running. So we can kill this. We can kill the to-do one here, right? I mean, it's not running, but we can delete it. Docker remove that. And then another one. Do we have another to-do app? Probably not. I want everything that is using that same image. Like, look at this. It's using the same image ID. Let me delete that. Docker remove. Oops. Clear. Docker remove that. Oh, no containers. Okay, great. So if I do, let me clear this again. Docker images. Docker images. I can see this is my to-do app, right? Or locally. I can delete that. Docker RMI remove image. Okay, it's saying it's being used by this container. Let's delete that container. So when you try to delete, every time I try to zoom, it just shows me the history. So I'm going to try to delete it again. Every time it's you try and delete an image, if there is a container, even if it is stopped, that it uses the image, is going to say, hey, you can't delete it. Either you can force it, so you can, in the same command, I can add -f for false or force, or I can just delete the container. So I can do docker remove the container, then I can do docker RMI the image. Now the image is gone. Docker images, and the image is gone. But what I want to show you is being able to run that application using the image that is in the remote. So I can do, let me clear this. I can do docker run. So the image goes at the end. The port is -p, any open port. I know 5656 is open. I know the application is using 5151, so I have to use that. I can give it a name, right? To do 2 or to do 1, and the name of the image. So since I want the remote image, I have to give it the full name. It's going to be SuperSQL / to do demo. If I just hit run right now, it's not, because it's not going to find the latest. Remember, if we don't specify the actual tag, it's going to try to get the latest tag. We never pushed the latest tag. We only pushed 1.1. So that's not going to work. And sometimes, even if it fails, it might have used up the name. So if I do, let me do docker ps-a, I want to check like the name, the to do one name is not taken. It's not. So we could run the same command again to run it, but we have to specify the tag 1.1. If I run this now, as you can see, it said, hey, I can't find this image. I'm pulling it. So this is literally the command you need to run to if you want to run that container from the image I just pushed. Right? By the time you watch this, I might have pushed more images, so they might have more tags. I won't change the name, but I'll change the tag as I push a newer version. Okay, now the app is running. I can literally access it. Not this. This is the logs inside, right? So I can open a new tab. If I do Docker PS, I see the application running somewhere here, smaller so we can see it. It's running on port 5656. And if I go to my browser, run there. What did I miss here? Oh, I missed 10, so it doesn't know where to go. There you go, right? The new app that run. Now, another key thing I want to talk about is let's look at our tasks. Actually, this is a new container we run, right? When we look at view tasks, the task we created earlier, the ones that say, what was it, like take the crash course or something like that, it is gone, right? It is gone. So what happens is, very important thing about Docker is, when you get rid of a container, you get rid of all the data. Remember, that container is its own little computer, right? So you have your own computer. Inside of your own computer, you're running another little computer, and everything you do is happening in that little computer, the inside one, the container. Now, when you delete the container, when you get rid of the container, all the data is gone with it, right? Imagine how scary that is. You run an application like this, your users are using it, they're doing a to-do items, they're creating stuff, they're creating data, and then you have a newer version of the application, which means you have to run a new container. When you run a new container, you get rid of the old container. That means all the data is gone with the old container. So what do we do with that? There is a concept of volume, Docker volumes, and we're going to look at that next. Now our application is running. We need to talk about volumes. Volumes are extremely important depending on what kind of application you are running. Especially if it is an application that users use or you use and it actually creates some kind of data, you have to understand volumes, because containers, when they're gone, they're gone. The whole point of Docker containers is you can just spin up a new one anytime you want. When you have code changes or any kind of change, you build a new image and you create a new container with the new image. So you update your code. So in order to do that, you're going to kill the previous container. You're going to start a new container. So that container is gone. And remember, a container is like its own isolated little computer. And when you delete that, all the data is going to be gone. So what volumes allows us to do is, when we write data inside of that little container, that data is actually written on the host machine. So on my laptop right now, when I write data into the container, I want it to automatically save that data on the computer. So when I delete the container, all the data remains. That's really the main point of volume. And when I spin up a new container, it's going to have access to the data that was previously here. And that's what volumes allows us to do. And let's take a look at it. So for example, here we have our to-do app running, right? It's running on 5656. If we create a to-do, let's go to home, or just create new task. I'm going to say ABC XYZ, right? Whatever, XJYZ, create add. Right, now the to-do is created. If I stop the app, the same container, it is fine. So I have the container running. Let me open a new terminal here. Let's use the UI just for because we haven't used it. So this is my to-do app running right here, right? It is running on 5656. I don't think I can make this any bigger. I'll do it in the, oh, there you go. So let's say I'll stop it. Now the container is stopped. You can check here, you can do Docker PS. You don't see that container running. It's very hard to see because of how it shows up. If I do -A to show all, the to-do app, let me make it a little smaller, and in the editing we'll zoom to the different parts. It's still pretty big. Let's do this. I'm going to do clear. Yeah, it's really big and hard to see. If I do Docker PS-A, you see my to-do app, right? Exited 30 seconds ago. So we can start it. So I'm going to take the name. I can do Docker start the image, the container name, or I can also hit the start button right here. Either one would work. So I'm going to do that. So it is started. Now we can see that it is actually running. And if we go to the application itself, refresh the page, our to-do item is there. So what happened is the to-do item, the container, we shut it down and we restarted. We never deleted it. We never got rid of the actual container. But that's because we never made any change to the application, and we just literally just shut it down, started up. We did not create a new image, a new container, or anything. But normally when you make changes to the application, you create a new image, you push it to the registry, and then the CI/CD pipeline takes that image and deploy it to the server where the application is running. Now let's do that. And before we do that, let's look at the application itself. So when we look at the application itself, what I want you to see here is, I'm going to keep this. We can close this to make it easy to understand. So the way the application works, every time we create a task, is creating a file in this tasks folder. So right now, the one we just created, let's see how, oh, it's not in here, right? Because this one is my local, it's not in the container. The one we did is in the container, its own little computer, all the files are in there. So we can go in the container. That's another thing I want to show you, is another command you have to know is going into the container. So when we look at this cheat sheet, common commands, there is this exec, the last one here. Okay, that is a command you use to go inside of a running container. Just like if you have a machine, a remote machine, you SSH into it to see what's going on inside. And now you have a running container, which is like a new laptop, a new computer, a new machine inside of your machine. Its own file system, its own everything. It's like literally just its own little thing. You want to go inside and see what's going on. So let's actually do that. So we know the container name is to do one, right? If I do docker ps, you can see to do one and it is running. I can make it a little bigger now. Let's clear this. Docker ps is the first one here. Okay, you can take the name or you can take the ID. It doesn't matter. It's very hard to see when I have it, when it's zoomed out, because it's just way too many things. Now, this is the one. I can see it's one line here. I'm going to take the ID. I'm going to clear. I'm going to do docker exec. That's the command. I want to go in the container and I want to be interactive. So IT, we talked about that. The container name, and you want to start a shell. You want to start a shell like a bash shell or something like that inside the container, and bin bash. Okay, look how the prompt is going to change. There you go, the prompt changed. I'm inside. Okay, now I'm inside the container. So all the commands I do, everything I do is in there. It's not on my laptop anymore. It is actually in the container. It's a little container. So if I do pwd, where am I? I'm in the app folder. If I do ls, I can see all my application. How come it is in the app folder? Because if we remember how we built this container, or how we built the image in the Docker file, what we did is we created an app folder. We copied the requirements.txt, we installed the requirements.txt, and we copied everything else into here. We never changed the working directory. We're still in the app folder. So we copied everything into the app folder and we run the application. So when I interact with the application and I actually create a to-do item and the file gets created, it's in that container. So I should be able to see the new file we created. So this is the application here. If I do ls-la, maybe it's easier to see. There's a tasks folder, right? Let's go into there. Task folder, ls-la. We should see our new to-do item, which is this abc.txt. Right, this abc.txt is the one we just created today. In fact, this is December 20th. You can see that it is created. Okay, I'm going to exit this container. Let's clear this, exit container. Now, if I do docker ps, I get the ID, and let's stop it and let's delete it. So to stop it is docker stop the ID. Now it is stopped. If we look at the UIs, because it's easier to see, you can see it is actually stopped. There is a run button here. We're going to delete it. Docker remove the ID. Now it is gone. Now if I start a new container, it's brand new, fresh, everything, right? So everything I created, everything that was in that container, the to-do item that I created is gone, it's deleted. So all we need to do is we need to tell it, when we run it, we need to tell it, hey, when you save stuff in the container, actually save it on the local machine. So what we got to do for that is, let me see if I can draw a little bit. So here, let's say we have a folder on our machine. Let's say this is our folder. And now we have the actual container. And inside of the container, there is a folder where it's saving. So what we're saying is when you save it, instead of saving there, this folder is the same as this folder. So it's actually going into our laptop. And the way we do that is we're going to give it a dash, or we can do dash volume, or normally you just do dash V, and you're going to give it foo bar, the folder on our machine, and XYZ, right? So what we're saying here is this is the syntax basically to tell it what value. We're saying, hey, this is the folder on the host machine. In our case, I'm hosting the container on my laptop, right? So my laptop is the host. On the host machine, we have this folder. In the container, whenever you write something into this folder, it's actually writing it into this folder, right? So that's literally what it means. So in our case, where is it writing? It's writing it inside of app. Let's see. This is not our command. We have the app and we copy everything into the app. Inside of /app, we have the tasks folder. So it's writing into the task folder. So our command needs to be, let's see, do we have a runner script? we have a push build script. So to run it, our command, let's see, we have it here. We ran it earlier. So we're going to run it using the same port because now the container is deleted, the port is available. So let's take this command, let's put it into a new file just so we can see it easily. There you go, right? So this is our command. Now we're going to add one more option to it. We can break it down to multiple lines so it's easier to see. I'm going to add escape character. So all of this is the same thing. So we're going to add one more -v. Where do we want our stuff to go, the data to go on our machine? We could create just a folder, right? I can say make dir, let me clear this, I'm just going to do it in the root, make dir main tasks folder. Okay, cd main task folder. If I do ls, there's nothing in this folder. If I do pwd, that is the folder here. Okay, now I can take this folder, I can say this is the folder on my machine, right, on the host machine. Then I'm going to say bind it to app tasks, because I know in the container the task folder is here because I went inside earlier and I looked at where it is, /apps/tasks. Now if I run this container here, we're just going to take that command. We're going to let's open a new window. I just did Control-C. We're going to run that. Let's see, Docker require at least one argument. What failed? Oh, we didn't have the skip character here, right? It didn't know what this guy is, because this character, what it's telling it is the next line is just continuation. Just ignore the new line. So we're going to copy this and we're going to paste it. And there it is. Our application is running. Now if we refresh, there are no tasks, because now that task folder in the container became the new folder I created. So there's nothing in it. So I can create a new task. I can do this is new task, testing volumes. The spelling don't matter. I just created this task, right? Now if I come here, I look at my local system, the new folder I created, this is a new task.txt. There is a file in that new folder. The new folder I created, the new file. If I create a new task again, add a new task, abc, add a task. If I do ls, now I have another file. So every time I write stuff in the container, whatever I wrote in the container is actually being written on my host machine. So when I delete the container, which we can, let's do it in the UI, it's easy. This is the container. We're going to stop it, right? Docker stop image. We're going to delete it. Docker rm the image name, or the container name or ID. I did it earlier in the terminal. I'm doing it in the UI. I'm just showing you both, but I want you to do the terminal all the time. Now the container is gone, but the files are there. Now if I start a new container using the same exact command, let me clear this. If I start a new container using the same exact command, right? So where did it go? Our command. This is our command, right? Exact same command. The port I can change, the name I can change if I want to, but the volume, where the files are, I'm going to tell it, hey, inside the container, you have this folder where you keep all your tasks. But instead of using it, I want you to instead use the one that's in the host machine in this folder. This folder already has items. So I'm going to go just to show you the app is dead, right? In fact, it doesn't even exist. I'm going to run it again. Now I run it again, brand new app. All our data from previously there. Okay, that is one of the use cases for volume, so the data remains. But another one is so you can make changes to the application and it automatically gets reflected. Otherwise, if you make a change to the code and if you want to run the application with the changes, what do? You have to go build a new image and run a new container, right? Imagine doing that every time you make a change. I fix a little typo, I fixed this, I fixed that, I added a new feature. I have to build a whole new image and run a container. That is not very feasible. So what you want to do is you want to mount a volume of the entire application when you're running it. That way, the code that is in the container is actually the code that is on your machine. You're going to say the folder here is going to be the same as the folder there. Let me show you. So let's kill this app now. We're going to open a new tab. We're going to do docker ps. Get the ID. This is the ID. Clear. Docker stop. And Docker remove. I'm just running two commands in one. Oh, Docker stop and Docker remove. I can do Docker stop, then Docker remove. It's deleted, it is gone. Okay. Now what I'm going to do is I'm going to modify my command here. Instead of this folder here, I'm going to give it the folder where all my application exists. So if I look at this, I want to give it the app folder has everything here, right? So I'm just going to, let me just copy this, copy pass, and I'm going to replace this here. And instead of the tasks, I'm going to give it the entire app. So this is the folder where the app is, all the application file, the view. Let me go back there. All those things, the tasks, the template, the views, the main file, everything that the application needs is in this folder. So I'm saying, hey, take this folder and map it or bind it to the /app folder. In the container, if you remember, the /app folder is where all our stuff is. We created the /app, we put the entire application there. So now I'm going to run this guy. I'm just going to show you, this is the last thing we're going to do. Let me clear this. I'm going to run this guy. Now the application ran. Now it's actually it's running in the container, but it is using the code. It's using the code in my machine. I'll show you. So let's say we go to homepage. Let's make changes here, right? Let's make changes here. We're going to go, let's say I'm going to go to, I believe, templates, index, and let's change the background, right? Let's say I'm going to go to dark pink. It's going to be so bright. Now I refresh this. Remember, I did not change the code in the container. I changed the code on my machine, on the host. And now I refresh, it automatically changed. So what happened is the files in the container are binded to the files on my system. So they don't actually exist in the container. They're just on my machine. So the container for that particular folder, for this folder, /app folder in the container, is using my local folder. So every time it writes to the app folder, it's actually writing into my system. So when I get rid of the container, the stuff remains. And when I want to make changes, when I make changes in the local drive, then those changes will be reflected in the container because they don't really exist in the container. The container is pointing towards the local. So that's what volumes are. But this is called, there is 3 kinds of volumes. This is called the bind volume. That's the one I want to use all the time. Because I want to explicitly know where it is. But sometimes you're going to see just a simple name. Let's say my volume here. You will see something like that. That would work. That's a different kind of volume. What happens is you don't really know where it is. But it is on your local drive, but Docker is going to manage it. Docker is going to figure out where to put it. Later on, if you want to move that information or that document in files and stuff, you need to do a lot of investigation to figure out where Docker is saving all that. So for me, this is called a named volume. I don't like the named volume. I like bind volume, where I explicitly say, I want this folder. It has to be a full pass. It has to be a full pass. I want this folder to be mounted or bind to this folder inside the container. I want to be very explicit. Okay, so this is volumes. It's going to come time to time, but again, all you got to do is now you have the concept that you're going to be using AI to create runners and to create commands and everything. The AI is going to do it. If it doesn't do it, you have to ask like, hey, don't we need the data to be persistent? Don't we need the data to remain in the host? So don't we need to have volume? And you're going to tell it add volume. It's going to do it, and you're going to ask it to explain it to me. What are we doing here? How are we using the volume? And it is going to explain to you, because now you get the concept. Now you know the concept of the volume. You don't really have to know how it works, exactly how to use it, but you do know the concept of volumes and why they are important, especially when you're developing. It makes it a lot easier because now the application is running on Docker, but I could make changes, and my changes actually are reflected without having to build a brand new image. That is very, very useful. I shown that thing to a lot of developers on my previous job actually, and they really like it because it makes life a lot easier. All right, so that is the concept of volumes. Let's do one more simple example of taking our code and containerizing, Dockerizing it, creating a Docker file and creating an image and making it available to be able to run as Docker. In this case, we're going to do an application that is just going to run and just die, like a utility. It just have one job to do. Earlier, we did a to-do app, right? Where it's an application, a service. That's called a service when it's always running, accepting traffic and doing things like a website. This time, it's just a use case where it's like a cron job, a scheduled job. The particular example we're going to do is a scripting job. What it does is this script actually, what it does is it's going to go here. It's going to go into this page. and get the price and just print the price, right? Normally you would have scripts like that. I actually have a script like that for my friend that I scheduled, which would go to a competition website, get the price, and send them an email with those prices. You want to see how the prices are going up or down with your competition, or something you're tracking. Let's say you want to buy this polo shirt and you want to know when the price goes down. So you set up a Python script that's going to check the price every hour, every day, every week, whatever, and send you a message. So that kind of script is just a simple Python script like this that's just going to run one time, does its thing, and just stop. So Docker is a nice way to containerize it, especially when there's a lot of dependencies. This is very simple. There's 2 dependencies, but I'm just trying to show you the whole concept of doing this. So what we're going to do is we're going to ask our AI, you can do ChatGPT, whatever, we talked about it. And we're going to do cursor to create a Docker container or a Docker file for this script. So I'm going to say, create a simple Docker file to run the at script get, let me see, scraper get title. Is that what I named it? Yeah, that I should name it. I should rename it script. So this is, I had it like getting title, but this is going to be get price. When I check it in, we will rename it. Actually, let me rename it right now. And instead of get title, I'm just going to say get price. Okay, so it's going to create a Docker file. There we go. We created a Docker file. It's a Python script. So it started from the base image is Python 11. It's decided I'm going to do Python 11. You could have done 12 or 13, but this is fine. Just like our to-do app, it decided to create an app folder, copy the requirements, copy the file. We just copied one file. Earlier we saw with the to-do app, I think I have it right here. With the to-do app, we copied every single thing. In this case, we just need that one file. So we only copied that one file. And we have a CMD, which is the image that's going to run, I mean the command that's going to run when we run the image. So let's build this image. We'll do it manually, right? So if we do pwd, we are in that right folder. If we do ls, we can see the Docker file is there. So it's pretty much simple. It's going to be Docker build, right? That is the command. Again, I'm going to take you back to the cheat sheet. I really want you to use this. These are the key. If you go through this list and understand or use each one of those, then you know Docker. You know most of the Docker things you're going to be doing, okay? Like basically running, getting rid of, running, getting rid of. And all those are the main ones that you're going to need. And everything I'm doing here is that. There's a build right here. That's the one I'm using. Docker build, we're going to give it a name, -t. Let's call it price scraper. And where's the Docker file? Here. Because I need to be where the Docker file is. Everything's relevant. Okay, so I renamed the file. So errored out. I'm glad it errored out. And when you're running Docker build and you get an error, this is what it looks like. Kind of shows you exactly where it's failing. It's failing on line 8, this copy. And if you read this, it's probably saying not found, right? Because we changed the name of the file. So that's why it failed. So we changed it to get price. Okay, that's what we did. We're going to keep this. Now we're going to just repeat the same command. It should go through. This is pretty straightforward. Did it not save? Get title? No, get price. Why did it? I thought I just changed it. The AI changed it back. Get price. All right, let's clear this and run it again. There you go. I'm expecting it to pass because this is very, very simple. Okay, there you go. The image is built. If we do Docker images, we'll see the price scraper here with the tag latest because we did not specify what tag, so it automatically assumes latest. Let's run it. So we're going to do Docker run price scraper, hit enter. We don't need to do anything in this case, right? We don't need to expose a port because we're not expecting traffic to hit it. It's not a website where we have to go access it. It's just a simple script that will wake up, do its thing, and die. That's what happened. We did Docker run the image name. It woke up, it ran, it printed whatever the script is supposed to print. Where is it at? It's in here. Whatever the script is supposed to print, it went and it got the price, actually $20. It got the $20 and printed. It could be scheduled, it could be configured. Instead of printing, it might be sending out a text message with the price or an email with the price, or it might be saving a file somewhere in the database, things like that. But the idea is we packaged it into a Docker image. Now all we have to do is just run the image, or we can publish it. If you need this, I would have published it. I don't think I'm going to publish this one. That you build an image, you publish it, and in a schedule somewhere in GitHub Actions, in Jenkins, in GitLab, some CI/CD, somewhere when you want to run the script, you can just run the image. It's a little bit of overkill for something this simple, but it will give you the idea. And the Docker file is extremely simple. One thing I want you to know is I want you to get the concept from this, but usually it is not as simple or as easy as this, right? Because this is just one file, just one dependency, one file. But sometimes you have to do a lot of things, and the Docker file can be pretty big. Just as an example, here's another Docker file for my custom Jenkins. It's a Jenkins with Firefox installed in it, so I can run automation. And it starts, the base image is Jenkins. So I take Jenkins official image, and on top of it, I add stuff that I need and create a new image, right? Layer. So the first layer is going to be the Jenkins official image. And on top of that, I keep adding layers and layers and layers. Here I install, so Jenkins is basically like it's kind of like an Ubuntu. I forgot the name. Debian. It's a Debian image. So we're going to add a bunch of things, install a bunch of things to it, set up Firefox, that's what I said. It's kind of tough, right? Sometimes it works, sometimes it doesn't. And then set up Python. We got to install our own version of Python, install Selenium, all this. So you can see this Docker file is 106 lines with a lot of comments. And this one is basically 10 lines. The idea is it can just grow. It's not as simple as this, as always, depending on how complicated the application is. But the concept is the same. You're literally giving it instructions, what it needs to do to build an image. Do this, do this, do this, do that. It's like a blueprint, literally like a blueprint on how the image should be built. Okay, so you'll get a chance to practice this eventually for sure. But now AI is going to write all of that. All you have to do is understand what's going on. If you didn't know anything about Docker file, then AI is not going to help you. But now you know that you need a Docker file. You can ask AI to create a Docker file for you, right? That's the thing. You got to have domain knowledge. You have to know what to use AI for. That's why a lot of people are missing these days. Okay, so that is the last example we're going to see in terms of generating our own Docker images. The next concept we're going to talk about is Docker Compose. Docker Compose is a feature of Docker that is really powerful, and it has two use cases. The major use case is to be able to run multiple containers at the same time with just one configuration. You have one file, it's going to be a YAML file, and we're going to basically configure it to run multiple containers. For example, if you want to run a WordPress application, WordPress needs a MySQL database and WordPress itself, two services. Now you could run each one individually, right? You can run Docker run WordPress, then Docker run MySQL, and for them to talk to each other, you have to create a network, a Docker network, which is the third command. Then you're going to have to add those two containers into that network, right? So a lot more configuration for you to do, a lot more things for you to manage. But since you already know you're going to need two containers, and you know they're going to have to talk to each other, then Docker Compose with one command, it will create all of that. It will create the two containers, it will create the network, it will add the two containers in the network, and it will have them talk to each other. So that's one of the use cases, and you can have as many containers as you want. In QA automation, if you want like a Selenium grid setup where you have one hub and multiple nodes, Docker Compose will do that. Another one, the easy use case, is to just run a simple container. Basically everything we've been doing, but instead of remembering the commands and having to fumble like we did here, right? We added a file just so it's easier to maintain, and we can save this as a shell script, a bash file, or some kind of Windows bat file, and we can just run this. It makes it easier for us to come and change this. But this is old school. This is actually really good. I've used it a lot. Just put the command into a file and just run it. But Docker Compose will do this for us in a really easy way, in a professional way. So let's just quickly look at it. We're going to use it for a couple of the examples we used already. So I'm going to go to my AI. I'm just going to ask it, I'm going to tell it the image I created, created image price scraper. This is the most recent example we did. Create a Docker Compose file to run this container. Basically, it's going to be very simple. I don't think I need to tell it anything. For the other ones, when we need to map ports and things like that, that's going to be a different story. So let's take a look. So this is what it looks like, docker-compose YAML, right? That's the name of the file. This version here, it doesn't actually need it. It's not needed anymore. Let me ask it, actually. Let me ask the AI, do we need the version? They don't do that anymore. Docker got updated, and the AI is kind of like old school. It's not in its training, I guess. But I know for a fact we don't need that. There you go. It removed it. I didn't do that. It removed it, right? The latest part doesn't need it. So this is what it looks like. This is a very simple one. You have service. Inside, under the service, you have the name of the container. This is going to be the name of the container, okay? Price scraper. Well, it's going to use the folder name. We can just give it a container name. This is the name of the container here, right? This is the name of the service. This is for us. It's not going to show up in the command line. The image we're going to use is this guy. Didn't give it a tag. Let's give it a tag. Let's do, just so you know what you need to do, latest, okay? And container name, restart unless stop. So restart option, we didn't talk about that, but when we have a run command, let's go back here real quick. Even in this command, we can add a option called restart, okay? And I think it's probably like that, restart. I can do always, or unless stopped. Unless stop, like that's what it did here, unless it stopped. So what this basically means is, like, if the host machine gets restarted, if you rent a cloud machine and you run it in the cloud machine, sometimes in the middle of the night they restart the cloud machine to patch it for security and things like that. So if the host machine, the actual server where your Docker container is running, dies and starts back up, your container will start back up. If you don't have this right now, when the container dies, when the actually host machine dies, your container will die, and when the machine comes back, your container is not going to come back. So that's what this restart is. It says restart unless stop. So this is a really, really simple Docker compose file. Let's just check it out, okay? So we're going to do clear this, and the command is basically Docker compose up to say go ahead and run. So I'm going to do that. I'm in the right folder. You have to be in the same folder where that is. Right, so the problem was, there you go, I did not anticipate this. It finished, so as soon as it finished, it starts again. It keeps running over and over and over again because it was never stopped. Right, it was never stopped. So it finished, and it's just going to keep restart. So let me see how I can kill it. I did Control C to stop it. So in this case, the unless stopped does not make sense. So let's comment that out. Right, we don't need that. There you go. And I don't know why it is taking forever to stop. I'm going to do Control C. If I do, let's look at the UI, see if that container is running. It's not running, right? Now if I run it one more time, clear, Docker compose up is for to run, down is to stop. But there you go. Basically just run, and it stopped. Pretty simple. If you need environments and stuff like that, there's a lot of configurations you can do. Now the to-do app here, let's do the same thing for the to-do app. So we're going to go here. Let's go into the to-do app folder here, to the to-do app project. I'm going to tell the AI to write that for me. Let's get the image name. I'm going to go here. Let's go to images. And the image name we have is to-do demo, right? So press QA to-do demo. I'm going to copy that. To-do demo, blah, blah. Yeah, that's the one. Let's use that. So I'm going to say create a Docker compose file to run the to-do app, right? The image name or tag is this 1.1, and then use host port, let's say 5757, and we can tell it the volume to bind. Let's give it the volume. Okay, we're going to do this volume. We want to do it professionally, and bind the volume local drive, this guy, to main folder. Let's just see if we can figure that out. Right, so basically, instead of having this, we're going to have a Docker compose file. It's still working on it. I think it finished, and it gives you what to do, what the commands are, how to start it, how to kill it. You can have -d to kill it, to run it in the background, and everything else. So let's look at the Docker compose file. Okay, I'm just gonna, again, the AI is going to keep adding the version until they teach it better, but we don't need that. So there is only one service. So there's a service here, the to-do, and the image is going to be that guy. The ports, this is the most important one, right? 5757 is the host where the container is running, how we're going to access it from the outside, and this is the inside. This part, it depends on how the image was created. This part you cannot control. And there is volumes and exact same mapping that we have, and restart unless stopped. This is pretty cool. So we can literally run it using this. So let's clear this. Right, we can do Docker compose up, and we can run it in the background by doing -d. We'll just start and it will run in the background. Let's do that so I can show you how to do the logs. So one thing I also want to show you, Control C to kill that. You might see, if you're looking at a bunch of tutorials or documents and things like that, you might see Docker Compose up, okay, with a dash. That's the old school way. It's still supported, but it probably will go away in the future. But this is old school, and Docker Compose without the dash is the new way to do it, okay? So clear Docker Compose app run in the background. There you go. Says it created a network and it created a container. So when we look at it, this is a little bit easier to see. We're going to go to containers, and we didn't give it a name, so use the service name. I'm actually surprised with that one. The service name to do app, because there's no container name here. If we can give it a container name as one of the configuration values, we would have used it. So use the service name to do app, and that's it. It is running. We can access it. Actually, why is it the port not showing here? That is very interesting. I'm curious what's going on here. This is another one. This is the older one that we ran earlier. It's not exposing ports here, so I am very confused here. Let's see. I'm going to do Docker PS. Let me make it smaller. It's saying 50 seconds ago. Oh, it is exposed here. It is actually using the right thing. I don't know why the UI doesn't show it again. Another point that the UI, I don't like using the UI, okay? Or maybe because it's Compose. Okay, maybe because it's Compose, it shows it under here. This is a container name, to do app-1. That's a service name. Inside the service, this is a container. And let's look at the name. Yeah. It calls it, the container name is to do app, to do dash. It takes the folder name and the service name, like joins it together and gives it a -1. Anyways, let's see if we can access it. I'm going to go to 00. It's going to be 0.0.0.0. In this case, we run it at 5757. There you go. Our latest app is running. So this is a simple Docker Compose. We can give it a name. So let's stop it. We're going to do, before we stop it, we got the container name or ID, right? If we want to look at the logs, we can do it in this terminal, Let's clear that. We can do Docker logs -f for follow, and then the name. There you go. You get to see the logs and it's following it. That should be part of, I might actually have missed it here. I'll add it to this list here, but Docker logs is really important, because if you run the container with the -d option, so run in the background, you're not going to see the logs unless you're going to do Docker logs -f to follow, so you get real-time logs. Let me show you. If I refresh this page here, right, refresh a couple of times, you're going to see the logs showing up here. Okay, so let's actually stop this container now. Docker Compose down. There you go. It will actually stop it, and I don't know if it actually removes it. Docker PS-A. It actually did delete it. It not only stopped it, it stopped the container and deleted the container. Okay, so that is what it is. Let's look at one more Docker Compose. This one is very simple. It just makes it easy for us to run things. It's a professional way to do it. Just one container. We can simply just run a command like this. And instead of pasting this in the terminal, we can just save this into a script and just run it. Or we can use a built-in feature of Docker Compose. This is much easier to read. And it's a good idea for you to be familiar with reading YAML files, because CI/CD configurations like GitHub Actions and GitLab, they both use YAML files like this. All right. So this is very simple, but let's just do one more for WordPress. We're not even going to run it, but I want to show you what it looks like. So I'm going to create a new agent here. Let's see, clear chat. But I normally just close this, open that, a new agent. I'm going to say create a new folder and create a complete Docker Compose to run WordPress with MySQL. Okay, hopefully it's smart enough to figure out, hey, I'm going to need to create volumes and things like that. But let's see what it does. But I just want to show you a little bit more involved Docker Compose that has multiple containers. What we saw so far is just Docker Compose just to be able to run one thing, but usually you use it to run a lot of different containers at the same time. With WordPress, it's two containers. So this is not done yet. So we're going to wait for it to finish. Well, I think it kind of just finished. So let's look at this. I'm just going to say keep file. We're not going to need the version. I mean, it's okay to keep it, but you will get a warning, and eventually you probably will start to fail when they completely stop supporting it. So you have a service. Under the service, you have DB and WordPress, and you have another section. Like it's the same level as the service. This is kind of like Python, right? The indentation matters. In YAML file, indentation matters just like it does in Python. So top level, you have services, then you have volumes, then you have networks. Okay, so this is going to be one of the containers, and this container is going to use MySQL 8.0. It's going to give it this name. It has the restart option. It has environment variables. So this environment variables depends on what the image needs, what the program needs. MySQL, the way they design this image, you have to give it the like a root password. Okay, those two are optional. You can create a user for the MySQL database that your application is going to use. So whoever designed the application, if it needs environment variables, this is so simple. You're going to set the environment variables just like this. You're going to list them. Okay, you don't list secrets like this, but environment variables, and you can pick those environment variables, the values from the actual environment. So you can do that for like secrets, for the real passwords and stuff. Like you don't want your password, the real root password, in here. You're going to have another variable for the password. Okay, you definitely don't want your password to be inside of your Docker file or Docker Compose file. Then you have the mount volume. So it's using the named volume, right? So here it lists out all the volumes. It's in the local drive, but it's not the same way I showed you where you tell it exactly where to save it. This is the kind of volume where Docker is going to manage it. You don't tell it where to save it, which I don't like. I typically like to tell it exactly which folder to use so I can just go find it easily. Right? It creates the network, and this is new for me. It added a health check where it's going to execute this command to make sure the container is up and running. Then there's another container for WordPress that has basically using the latest WordPress image, a bunch of variables. It needs the same variables so it can talk to the MySQL database. It didn't set the port here because it's going to use the default 3306. So the idea is basically it just spins up two containers. If we do this right now, if we say cd, let's go to WordPress, and if I do Docker Compose up, you're going to see it pulling a bunch of images, right? I don't have a MySQL image, so it's going to pull the MySQL image. The WordPress image we already have, so it's probably not going to need to do that. If we look at our images, we have WordPress latest, right, from before, and MySQL 8.0, it just pulled it. So it's going to pull the two images that it's going to need, and it's going to run it. So you can see this is the things it did. It created a network, it created a couple of volumes, and it created a couple of containers. So Docker Compose keeps things organized, and it would allow us to run multiple containers in the same network so they can talk to each other. So this is a crash course, and I don't want to get too much into Docker Compose. I just want you to be aware of it. Again, when you have multiple containers you need to run, you're going to go and ask AI to write it for you. That is the key. That's really the key here. All right. Congratulations. If you made it this far, you've learned a lot about Docker. Docker is a term you hear all the time. It is really popular. It is really powerful. And now you understand why. I hope you do. We did everything you need to do with Docker. Of course, you need to practice, right? Watching a video, doing small little projects is different than actually using it. So go ahead and practice. Go back and Dockerize, run the applications that we did. Basically, everything we did in this course, you should do it. All the code is available for you. The link is in the description. And if you want to go further, go ahead and join my program, right? I have a free 1 month and a full QA automation training. Docker is part of that. As QA automation, you got to work on CI/CD. And as we just saw, Docker is a major part of CI/CD, and every single QA job right now is asking for CI/CD. So go ahead and check out my program. You're going to be a professional instead. So in this course, we saw the concept, right? The theory of why Docker solves problems, why it solves it worked on my machine problem. So we saw the theory of what Docker is, how it helps, what it does. Then we saw how to use it to run existing code. We ran somebody else's code, somebody else's application. Then we saw how to containerize or Dockerize our own applications. We take the code that we wrote, whether it's a full-on web application like the to-do app we did, or just a small script like the price scraper we did. We take that small thing and we make it a Docker container, so it makes it easy to run. And the power comes when you want to actually deploy it to the cloud. Like the power is not about running it on our laptop like we did. But we take everything we learn and we deploy it in the cloud, and we run the code or the containers in the cloud. And right after this video, my next project is to go ahead and Dockerize my application. I'm building this SaaS, right? Software as a service for social media management app. I didn't even give it a name yet, but I use it to manage my social media. It even generates videos, generates carousels and things like that. So I built this app. Right now it's on my machine, it's on my laptop. I have a production version and a development version, but both of them on my laptop. The next thing I want to do is I want to deploy it into a server. For that, I want to do it professionally. So I want to create a CI/CD pipeline. And for that to be very efficient, I want to Dockerize it. So the next thing I'm going to do is literally go ahead and work on Dockerizing my application. It's going to be a little bit more complicated than the one we did. So it's going to be really fun and really challenging. And so make sure you watch that. I'll put the link to that in the description as well. And if you want to just follow me build this app from scratch, go ahead and make sure you subscribe. Go watch the video to see real live application of Docker. Everything we learned right now, literally everything we did, you're going to see me use it in this application. In fact, I'm going to use the Docker Compose because my application has a front-end service, a back-end API, and a database. So it's a really professional application, and I'm going to take everything we learned so far, and I'm actually going to use it in the real world. So make sure you check out that video. It's going to be the first thing in the description, actually, so you can see it. Oh yeah, we learned the theory, we did a little bit of practice, but are you really using what we taught us in the real world, in a production environment? And that's exactly what I'm going to do. I'm going to do it in GitHub Actions. That's one of the most popular CI/CD tools. And enjoy the journey and give me a comment. I would love to hear your comment. I mean, you watched like a 2-hour video with me right now, and just what you feel about it. If you have any questions, I'll be very happy to answer them. So I'd like to see your interaction in the comment, and I'm always there to respond. And thank you for watching this. And the next thing that show up on the screen is I'm pretty sure you're going to like.